Are we ready? Yep. We're getting started again. Get your seats. I know lunch is really exciting, but the talks are going to be even more exciting. If you guys can sit down and like, woo, yay. Yay! Welcome back from lunch. We're going to get started. I'm Christina, your MC for the afternoon. All right, a couple rolling announcements from the podium. Some things I need to tell you before we get started. We repeat these multiple times so that they will sink in. Please be kind to the Wi-Fi. Don't stream the conference while here in the conference. Please don't do that. That would just be weird anyways. Keep multiple devices down to a minimum. Just be aware of Wi-Fi usage. Notice to speakers, try to come up here and make sure your slides are ready, whatever break is before your talk. If you need any help, there's a bunch of people up here who can help you get set up and prepared. Please do use the microphone for questions and speakers to make sure that everyone can hear it and it gets to the transcription. There is an accessibility page on the conference website if there's any accessibility need or question that you want some help with. And, be aware that seriously, Secret Service will show up, exclamation mark, if you try to do something janky with the Wi-Fi, I guess. So don't capture and clone IPs. Don't hack the network. Secret security will show up, unless they're already here. Oh, man. Okay. All right, before we get started, announcement for today after lunch, let's see. I'm going to say some thank yous to our contributor level sponsors. Our sponsors really make this happen and try to keep this affordable for people, so thank you. Our contributor level sponsors, the Rockefeller Archive Center. Oh yeah, let's clap for them. University of North Carolina School of Information and Library Science. The University of Arizona, University Libraries. Yay! The Library of the University of California, San Diego. Northwestern Libraries. Two more. The University of Rhode Island University Libraries. And the Harvard Library. Thank you, all of them. Yes. And finally, our duty officers for the afternoon, they are in the back designated seats, are going to be Becky Yus and Mark Matienzo. They are back. Can you guys raise your hand really quickly? Those are our duty officers for the afternoon. Cool. All right, let's get to some talks. We're starting Group 3B. The first person we have up is the Liz Woolcott, and she will be talking about use versus reuse, assessing the value of our digital collections. Yeah. All right. You all ready? Yes. Hopefully this. Yes.
Okay, can you guys hear me? Okay, good. So, well, this is a really big room and a slightly terrifying experience, so I hope you'll excuse me. It'll be awesome. Thank you. So this is my first Code4Lib, and this has been an amazing experience. I can tell already this is a group that really is interested in investing in collaborative work. And so I hope that this presentation will resonate with you, and we can get some more feedback. So I'm representing a project team that's composed of 6 people. And if you have any questions about this project along the way, please feel free to contact anyone on this project list. I will show this slide again at the end of the presentation for reference too. We're also talking about this project on Twitter under the hashtag #DigReuse. And we've also put together a website that you can find all this information at reuse.diglib.org. So just really quickly, our research team includes Santi Thompson from the University of Houston, Elizabeth Kelly from Loyola University in New Orleans, Caroline Mulia from the University of Southern California, Jenyo O'Gara from the Virtual Library of Virginia at George Mason University, Ayla Stein from the University of Illinois at Urbana-Champaign, and myself from Utah State University. We're also incredibly fortunate to pull together a talented advisory board, all of whom have contributed their knowledge and experience to this process, so we want to give them a really big shout out, as well as to the Digital Library Federation, who has handled the difficult parts of the grant funding for us, and also provided us space, digitally, physically, and organizationally to work on this project, so our thanks to you all. Okay, so I want to start off by asking you all to think about how you measure the impact of your digital collections. Do you use it in decision making? Do you gather web analytics, user stories, citation counts? And then I want to ask you, what do you do with this data? Do you use it in decision making? Do you share it with stakeholders? Is it worth your time to investigate the impact of your collections? So in case you were thinking, I'm here with the answers to those questions, I'm just going to be upfront with you, I don't have them. Our team is actually looking at this project and pulling in the data collection right now. So most of this talk will be a snapshot of what the community is currently doing and where the community thinks there's room for improvement. So first, let's quickly talk about the difference between use and reuse. Here are our definitions of use and reuse, and we would be interested in hearing your opinion on these, as they are a work in progress. We defined use as discovering and browsing objects in a digital repository, often described as clicks or downloads, without knowing the specific context for the use. Some examples are web analytics that capture metrics on initial access, like Google Analytics, or the metrics that are supplied by your content management systems. We define reuse as how often and in what ways digital repository materials are utilized and repurposed, knowing the context of use. Examples would include the metrics of what and how often your digital content is shared on social media or reverse image lookup analysis. So a little background of why we wanted to study reuse. Back in 2014, the DLF's assessment interest group formed a small working group to look at the current literature on use and usability in digital libraries. We created a white paper that was released in 2015, and I've got a link on the slide here for you. We discovered a number of articles written about the UX for our digital content management systems, but very little on how material is actually being used or how to evaluate the impact of digital collections. So this led to an even smaller working group splitting off to dive into this topic. We called the project Developing a Framework for Measuring the Reuse of Digital Objects. But since DFRMRDO is not a pronounceable acronym, we just call it reuse. We were very excited to receive an IMLS National Leadership Grant last summer to fund the exploration of current assessment practices and the use cases for a reuse assessment toolkit. Our work is taking place over the course of the 2017-2018 fiscal year and will conclude this coming summer. Okay, now digging into this project. Our stated purpose for the project is to develop functional requirements and use cases for a reuse assessment toolkit, which we have called DCRAFT. It will identify sustainable and vetted assessment techniques that can be applied to a broad array of digital library collections, support cultural heritage organizations in deepening their understanding of the ways users engage with, reuse, and transform digital content, and with the digital library community, develop approaches and best practices for communicating the economic, educational, scholarly, scientific, social, and cultural impact of their digital collections. By the end of the project, we'll provide a white paper, a grant report, and a ton of project data, which will be openly available on our OSF repository, which is linked here. Throughout the process, we'll also be posting about our findings and what our next plans are on our website, which is, again, reuse.digilib.org. So we took a twofold approach to gathering current data from the community. We are using surveys and focus groups to gather information about what kinds of impact measurements are currently being collected and what the profession felt could be done on a larger level to support the understanding of reuse. And I'll start with our survey data. For some starter details, the survey ran between September and October 2017, and we built it in Qualtrics. We asked a core of 10 questions, which could expand to 19 depending on the answer given. We had a total of 409 responses, 302 of which were usable. There were 130 respondents that answered all 10 of the core questions. About 56% of our respondents came from academic libraries. 10% was the next largest, and it came from public libraries, and then 8% came from museums. The remaining 26% were a mixture of archives, government libraries, historical societies, consortium, and other institutions. 30% of our respondents reported that they primarily served underrepresented groups. First, we asked them about the gathering of use statistics. And remember, these are metrics such as clicks and downloads, initial access. Most of our respondents did collect some type of use statistics, about 80%. We also asked them about the collection of reuse statistics, which, if you remember, are metrics such as social media sharing or reverse image lookup. And surprisingly, most of our respondents, not surprisingly, most of our respondents did not collect reuse statistics. Only about 40% said they did, but that was still much higher than we had expected. So when asked why they collect use statistics, these were the most commonly given answers: to improve their digital collections and services, to demonstrate the impact of their collections on scholarship and research, to prove the return on investment for their funding stakeholders, and to improve their selection of digital content and digitization decisions. The survey explored what types of platforms and methods were used for collecting use and reuse data, and found that the most common platform for collecting use information was Google Analytics, or the statistics provided by their content management systems. For reuse respondents, those who collected reuse, that is, noted that they were using social media supplied metrics, alert services, and reverse image lookup as the three most common methods. When looking at the most common types of data collected, use data tended to be the number of visitors to a website, the number of downloads, and the number of clicks. For reuse, the data tended to be citations and scholarship, published or reposted digital objects, and digital material that is published in physical media, such as print books or exhibits. We also collected information about what prevented respondents from gathering use and reuse data. For the most part, those 20% of respondents that didn't collect use data didn't do so because they had really new collections or were currently putting their first collections online. But apart from just getting established with digital repositories, most respondents to this question were not collecting use information because they lacked staff or staff time to dedicate to it, or because a different department in their institution did that work, and also because it was not a priority. For reuse, most of the 60% of respondents who did not collect reuse information indicated that was because there wasn't an accepted methodology or system to do so. They also reported a lack of staff and time to dedicate to gathering reuse information, that it wasn't a focus of their institution, and that they didn't have the ability or resources to gather that information. One respondent summed up their situation by stating that collating data from the digital collection use and reuse would cost manpower hours that the board of directors would not understand. When asked about doing assessment overall, respondents indicated that they weren't doing assessment because they lacked staff, time, and money, and you're starting to see a theme here. This is a very common issue. But apart from that, the next most common reasons were a lack of field-wide standards for measuring and discussing impact, as well as the experience and tools to help us gather and interpret the data. While I noted 2 slides back that one respondent didn't think their board of directors would value time and effort spent on gathering assessment data, another respondent wrote this, noting that reuse is highly valued by their stakeholders. This is one example of the wide variety of opinions about assessment. Some stakeholders would value it, others would not, and most of this depends on having adequate staff, time, and resources to do our jobs, and also understand how we impact our communities. So the focus groups also provided a lot of qualitative information and discussion about the topics of reuse. They were particularly helpful in refining our definition of use and reuse in ways that are too difficult to do with surveys. Here's a breakdown of how our focus groups are conducted. Please note that the final focus group, which is focus group number 6, is very likely, but we're still waiting some final confirmations on logistics before moving forward. So in total, we should have 5 to 6 different groupings, half of which are in person and half of which are virtual, with an average of 8 participants each. For both the in-person and virtual, there are 2 sessions. So that means in total, we will have 10 to 12 different focus groups, discussions representing 40 to 48 different views and voices and viewpoints, and a whole lot of discussions to code. We are structuring the focus groups around 3 topics. Our first topic was an information gathering focus in order to set a baseline snapshot of what institutions are currently doing to gather use and reuse and how they are utilizing that information. It is also where we are working on refining our definitions for use and reuse. The second topic for the focus groups 3 and 4, will discuss the technology and standards that our communities can use to gather reuse data. And our in-person focus group for that will actually take place tomorrow here at Code4Lib. The third set of focus groups, group number 5 and possibly 6, will discuss cultural implications of gathering and reuse information and also privacy concerns for our communities. These last two topics, the technology and standards and the cultural issues and privacy, were driven by the baseline information gathered in the surveys and the first round of focus groups. So far, this is what our participants have identified as a need for technology for tracking digital content. So seeking metadata, or metadata that stays with digital items. This could include attribution or origination information, digital provenance, and object identifiers. They also identified data dashboards as a really big need, which they saw as a tool or a single dashboard to collect various analytics together, to see Facebook statistics alongside Pinterest pins, Reddit, Instagram, Vimeo, YouTube, Content DM stats, Google Analytics, etc. This is important for being able to examine large-scale trends and crossover statistics between these platforms, particularly for people sharing or resharing digital library content. They also identified DOIs, or unique identifiers, for all digital objects as essential for tracking usage. These need to be sticky. Keeping across platforms could help show impact. Participants also pointed out the need for more standard interoperability between institutions and more training, including standards to help libraries gather and measure use and reuse in a standard form to aid in analysis and understanding, instruction on how to share assessment information through storytelling or through impact statements. They wanted training on how to turn that information into decisions, such as what to digitize and what not to digitize. Participants noted that there was a lot of sharing that could be done among cultural heritage institutions, such as sharing our collection assessment information more widely. So sharing information such as, we found that digitizing our yearbooks resonated well with our alumni, which resulted in additional funding for the library. Or, we found that no one really cares about our extension reports, so we're not going to digitize them. Being able to look overall trends of what is resonating with the library community, or with the library's communities, could lead to better decision-making overall. Along this line, building a platform to aggregate this data could also help in looking at the overarching trends of digital content use. It can help point to types of content that should be digitized in the future, as well as used to talk about library impact on a national or international level. Participants also noted that there was a professional need to be mindful of the implications of collecting data about our community members, particularly where it may have a negative impact on underrepresented groups as well as individual privacy. So from all the data gathered so far, the project team is getting a sense of what a community needs in a toolkit. Our key takeaway in this process so far is that the cultural heritage community needs technology to do their work more effectively. Being able to trace digital content use and have all of the important metrics gathered together in one platform would help to alleviate the amount of time and staffing spent gathering assessment information. It would also help level the playing field between well-funded and underfunded institutions, allowing them all to get a sense of what digital content is useful to their communities. The next is training, both on how to gather assessment data and also how to interpret it effectively. The community would also like common standards. Developing or pointing to a common standard for gathering assessment data is vital, both for building assessment platforms and also for comparing apples to apples when looking at the larger trends. They would also like to share their findings. Examining the larger digitization trends as well as the impact of the digital collections can help inform decision-making. And they wanted conscientious assessment, developing best practices for assessment with respect to individual privacy and cultural and ethical implications of assessment practices. So if you have any questions, feel free to contact anyone on this project team. This is an ongoing effort and will continue through the end of the fiscal year. And look for more updates coming then. Thank you.
So at this point, we have time for some questions if people would like to ask a question. We go to 30, I think, for this one. 20. Timekeeper. Sorry? 105. Okay, cool. So never mind. All right. All right. So anyways, so the next speaker that we have coming up is going to be Beyond Open Data by Sean Averkamp, Ashley Bluer, and Matt Miller.
I can set this up in a prompt amount of time.
While Ashley's getting this ready.
Yeah, go
Sorry. While Ashley's getting this ready, we just want to give you a heads up that there are a few GIFs in this presentation, but they are all very slow-moving and gentle, and they're all very crucial to understanding our presentation. So.
Yeah, so we'll need this not mirrored by the AV team. Thank you. And I will drag this over. Check it out. And then I will bring this back over. How do mice work? I want to refresh. Oh no.
Uh-oh. Cancel.
And then, okay.
Yay, okay. All right, I don't need this then. I'm just gonna put it. All right, hey everyone. I'm Sean, and this is Ashley. And here over in the corner is Matt Miller on tambourine, who couldn't join us in person today because he had to go talk about open data in Australia. But we really wanted to have his presence here with us. So Matt and Ashley and I all used to work together at a big public library in New York. And because we really liked working together, we decided we wanted to propose a project for Code4Lib. So this library had done some really innovative work over the years in creating and releasing open data sets. And each of us played some role in creating open data, publishing it, documenting it, and even reusing and remixing it. But at the end of those projects, the data was left live on third-party servers, so we thought that for this project, maybe we'd try packaging it all up and depositing it at the Internet Archive or somewhere else more secure and discoverable. But as we started talking about the work of packaging and saving it, we started thinking about how few people have actually used open data. And we started feeling like, who cares? Like, why bother? Like, why do we all publish this stuff? So yeah, it makes for a good press release, and it's a noble enough aim to require it for a grant, but I mean, how many of you have done anything with open data? A few hands? Oh, good, more than I expected. How many of you want to, but you don't know how to start? No, not very many people here, okay. And how many of you don't know if you want to because you don't know what open data sets are available or what's in them? A little more, cool. So this really left us at a loss for what to do for this talk, but you all voted for us, so we had to come up with something, and so here's what we did. So why do we do this? I don't think that we have a good answer yet to the why, but we know that as a profession, we haven't given open data a fair chance for reuse because we haven't given it the care and thought that we give our other library projects like websites, catalogs, digitization, digital humanities projects, or digital preservation. But I can tell you why people don't care. One, many of our data formats are hard to work with. If it's not in CSV and it can't be open in a spreadsheet, most people aren't going to work with it. Two, our library standards are incomprehensible to many people outside libraries and to many people inside libraries. And three, there's just not enough context around data sets of collections or documentation to help people interpret it.
Yeah, so who cares? A better question is maybe then who should care? So who cares? We care, I care, you care, we all care, but this is our stuff, it's our field, and we're dedicated to these things. It's like a core value of what we do as librarians. But who would care? Also, other people who also care or should care are institutions, sometimes that's a problem, yours and others, researchers, other librarians, yours and others, digital humanities people, educators and their students, and general consumers, people who just want to explore. For example, a hackathon participant who wants to engage in a project and have fun writing code in a group, but they need something solid and practical to work on during a short period of time. They can benefit from this data and good data packaging. I think it's important to have an understanding of the types of people who might be interested in using your data, but also open to the idea and aware that you can't always know all the potential use cases for your data. So considering all of these reasons not to care, for this project we decided we wanted to experiment with some open data sets to learn more about and how to get people to care, including ourselves, burnout recipient, me. So I'll start with a project that Matt worked on, so I'll be representing him and his work here. Matt wanted to work with the Library of Congress's MARC data and think about how it could be released in a more broadly and user-friendly data format. So with the data available not as raw data, or raw MARC, but as maybe a table or a database or a CSV, it could be easier for people to understand a data set, and the data could be used and explored a little more easily. So by the way, Matt is great. He's been doing a lot of really interesting work with the data over the past few months since it was released, and the Library of Congress is great. Thank you for releasing this data and putting it out there. So you can find Matt's stuff online on the internet. So I feel like I didn't initially appreciate the work that Matt had been doing in this department until I went to check out some of the public data myself, and I ran into all these sort of like dark UX patterns that initially pushed me to purchase MARC records for $20,000. And only at the bottom is there a link to some other links, and the data is split into 41 chunks. It's not easy to access, and there's not really any context, especially if I were a user who didn't know what MARC really was or what could be in it. So anyway, after doing this mapping work, which we'll link to later, and he used Dataset, which is a framework for building a quick and easy SQLite database. This is him showing us how easy it is, pip install Dataset. Although sometimes that's easier said than done, right, Python. But here's a GIF of the results. The results are functional, but Matt said the source data is still maybe a little too big for this framework. 10 million records is a lot of records, maybe a little too much for proper use of this particular application. But I mean, Library of Congress is the biggest library in the country, so yours is probably smaller. And he also noted that MARC data is complicated, but if you think about building your own database for a specific use case and releasing that as a data package, it makes things much more manageable. Also, he says this is maybe a cheap way of building up an API. So if you put an index on everything you wanted and you stay away from a full text search, you could totally set up some sort of simple API endpoint for other people to use. So now it's my turn. New person. Sorry. This study is sort of a general attempt at finding data to build a small thing on top of. I took the lazy way out, as I'm prone to do as a developer, and came across the Philadelphia Museum of Art's hackathon page, which had been set up as a public-facing experimental API. I appreciate the upfrontness of this page. It explicitly states that it's an experiment, and they're still in the early stages of infrastructure building. The quote on the website is, "We're sharing our work-in-progress version of what could possibly become our collection data access layer with you," which I think is really nice. So the API framework also comes with these Explorer tools, so I can test out the API calls right in my browser without having to set things up and deal with the raw JSON data, reducing clumsiness on my part and sort of letting me get to what I want more quickly, which is an understanding of what kind of data I can see and how I can grab it. What's on display right now is what I initially used to grab up images, but later down below, I saw that there's another API endpoint that retrieves data about everything currently on display in the museum, or at least at the time the API created, I'm not sure. But this is cool, and without this Explorer or this auto-generated documentation, I might not have even known that this endpoint existed. So to celebrate how nice open access to data was, and with a quick and easy-to-use API, and how much I appreciate the Philadelphia Museum of Art for making this available to me as a developer, I made this game about smashing up all the art in the museum on display. The premise of the game is somewhat contrived. You're an eagle avatar, and the goal is to smash up all the art in the museum because you were just so pumped about the Super Bowl. So it loads up. There's like non-stop images just coming at you, and you can just bam, bam, bam. Never stops. Eventually, your screen can be filled. I also, following in line with the conference theme of using Comic Sans in the application. This is an example of the kind of thing people could do with your data. Maybe you don't want people to do this, but whatever. But for real, when I was thinking about this talk and building on data, I immediately went with the thing that provided me with the quickest and most understandable access. For me, that's an API, but for others, it might be a CSV. So I'm going to pass this back over to Sean and talk about the work her and others have done.
Okay, so I'm a metadata librarian at the New York Public Library, and I use our digital collections API a lot. I know a lot of other people don't use it, and I think that's mainly because it's hard to understand how to get at what you want, and we use mods XML to describe our items, which is just really hard to understand.
So it's great that we offer this data openly to the public, but it's definitely not a model for how to publish open data. We also get a lot of requests for pulling down metadata or images for specific collections, which is not straightforward at all in our API. So I wanted to write a Python script that would take a collection UUID, fetch the metadata and some image details for all of the items in that collection, and then map and flatten it to a CSV table schema, so that users of any skill level would be able to quickly get a sense of what's there and be able to explore the data using existing spreadsheet tools. So my goal with this was not so much to produce a finished product for sharing our collection data, although the script is up there and it works. It's really ugly, but you can try it out. What I really wanted to do was learn from the process about what is lost from mapping from mods to a flat schema, and think about how to make good decisions around creating a generalizable but responsible mapping that preserves as much meaning and context from the original metadata as possible. So this script also creates what's called a data package, and it generates a JSON file that describes the collection and the data, and it outlines the schema in a machine-readable way. I got really into the frictionless data initiative a little while back while I was researching a talk, and more recently I was helping another former colleague wind down a grant-funded project. Frictionless data is an initiative and a set of specifications maintained by Open Knowledge International. It's basically a container format for describing a data set or a bunch of data files in a machine actionable way. So if you're familiar with Docker for software, it's kind of like that, but for data. It's not the only data package spec out there, but what I like about it is that there's a growing community around it and a ton of tools for creating data packages, reading them, and analyzing them. I also like that there's a basic schema for interoperability, but it's extensible, so I think there's a real opportunity here for creating data package schemas that would suit our library and cultural heritage needs. So after helping set up data packages for our spacetime directory data sets, I wanted to try packaging up all of the other NYPL data sets that we've created over the years for the projects that are no longer being maintained. And I started with the data sets from our What's on the Menu crowdsourcing project because I thought it would be easy, but it turned out to be a huge archaeology project and taught me a lot about what kind of documentation we data producers could be keeping along the way that would put us in a better place for publishing and sunsetting projects. Because there were so many people from the project that weren't around anymore, I ended up talking to Katie Roston and Trevor Munoz, who documented all their amazing investigations into this. And we have 2 minutes left. So basically, they had some great things to say, which are documented elsewhere. But I'll just say that one of the biggest takeaways from all of this, there's a lot that we can do, but we're not going to have the time to do it, even with the best intentions. So the biggest thing that you can do is just put an open license on your data so that at least somebody else can reformat or repackage your data and share it.
All right, so there's a lot more we can say about this, and we put it in a GitHub repo. So we put together a data care guide for creating data sets that more people with different skill sets can use, and then we'll work with existing applications and tools. It can help you when releasing data sets or even help you advocate within your institution while planning data packages or application development. So this guide goes into the above issues of who cares about data and why you should care about them, but also gives recommendations based on the following 9 categories: consistency, context, licensing, planning, portability, publicity, redundancy, reproducibility, and simplicity. Actually, I'll stay on this. We also included much more information about the experiments we talked about today, and sort of we included some frictionless data packages so you can get inspired to create your own. We hope that you do. If you're really into this idea, please feel free to contribute to this repository via a pull request or starting a conversation in the issues tracker, or get in touch if you want to join in as a contributor. We don't know how much we'll be doing with this repository, but we'd love to start talking about this stuff more in our community. So we hope that you can start caring and sharing with us. Thank you.
20 seconds for questions. Sorry, that just got wasted. All right, great job. So before I introduce our last talk for this group, we are following right after this talk, going into lightning talks. So if you're giving lightning talks this afternoon, maybe in 20 minutes, 15 minutes, start figuring out how you can get up here to the front, and we can start cat herding you for getting the lightning talks round going. Okay, so now we have, from Wikidata to Scholia, creating structured linked data to generate scholarly profiles by Marilis Lemas Rojas, which I think yeah, and Jerry Odell.
Hey! Thank you. So I'm Jerry, and my release is how I say it, and I've been saying it for 1.5 years and getting it wrong. We're going to talk a little bit about Wikidata, but before that, a little introduction to where we work and why I want you to work with us. We're at IUPUI. It stands for Indiana University, Purdue University, Indianapolis. It was once a Jeopardy answer for what is the longest name of a university. We are proud that we've never had a football team. We have 30,000 students. Yeah. 30,000 students and no football team. And we have a pretty fun library, and we really love open access, open source software, open data. Our dean, David Lewis, was just named the ACRL Librarian of the Year, which is awesome, but he's retiring, so come be our boss and come work with us, please. So I'm going to turn it over for most of the presentation to my release, and she's going to talk about this pilot project we've been working on.
So essentially, for this project, we selected the IU Lilly Family School of Philanthropy. We wanted to, well, the reason why we selected this school is because it's unique to IUPUI. So for the purpose of this project, we wanted to contribute IUPUI faculty members' data and their publications to Wikidata to start building a free, open, linked data scholarly record. And the idea behind doing this is so that we could also generate their scholarly profiles using Scholia. And we envisioned that we could provide this as a service to faculty members. So Wikidata, of course, this is what we're using as a platform to store the data. Wikidata, this is probably not news to most of you, but it's the newest project in Wikimedia Foundation, developed in 2012. It's a multilingual knowledge base that essentially stores structured linked data, and is growing rapidly. There are over 43 million content pages right now, and they all get their unique identifiers. And so we're using Scholia as an interface to display the data. And Scholia is essentially a web service that generates researchers' profiles using Wikidata. So for this pilot, we selected just 18 faculty members from that school. Those are the names of the members, the faculty members. And we started by doing some data gathering. So essentially, we just store all that in a spreadsheet. So we search in Scopus, Researcher ID, VF, ORCID. We got their Twitter handles, if they had an account, LinkedIn accounts, Google Scholar IDs, ISNI. And we also looked at the school's website for their profiles. So with all that data, we then started creating Wikidata items, but we did first check Wikidata to make sure that they were not already there. So we created the items. This is actually a screenshot of one of the faculty members. You can see that there's a little bit of information here. And then after we created the entries for all the faculty members, then we moved on to create the entries for their works. And we did that in two different ways. One being entering the data manually, which proved to be a lot of work. And then but also doing that also helped us to get a better sense of how Wikidata works, the properties that we were supposed to use. And then we just decided to try this tool, the source metadata tool, which essentially searches bibliographic metadata based on PMIDs, DOIs, and PMCIDs. And then it pulls the metadata describing the item, as you see on the right-hand side. And the tool also offers, I don't know if you can see the pointer. Can you see the pointer? No. Okay, but the tool also offers a link to quick statements, which is another tool that executes automatic edits in Wikidata. So essentially, you have to be logged into with using your Wiki account to be able to allow the tool to make edits on your behalf. And the result is something like this. One thing that we still have to do was actually, even though we were using this tool, we still had to make some manual edits because there were pieces of information that we wanted in that entry. And I will show you in a minute the reasons why. So essentially the name of the journal that the work was published in, the number of pages, and then the language of the work. And if the journal was not already in Wikidata, then you actually had to create the entry for the journal as well. And so once we were done with that, we then had to create the entries for all the co-authors for that particular faculty, for each faculty member. And that was a lot of work too. As you can see here, these are all the entries that we had to create, which are the co-authors for that faculty member, Una Osili. So these are faculty members that are not necessarily, that don't necessarily work just for IUPUI. So these are faculty members across different institutions. And for that too, we did that work manually, but we also used this other tool, which is an author resolver. And it essentially links documents to authors. And so if the author is not in Wikidata, then it creates them for you. But if it is, then you have the option to choose the work and the author, and then it gets linked. So that results in something like this, where you have, so the author gets moved to the author property, because the tool will have it in the author name string. So essentially, it's just moving it up, and then we will have to clean this up. I don't know if this is going to work or not, but I was going to try to show you how Scholia actually looks instead of just having screenshots. Oh, cool. Oh, no, you cannot see it. Wait. Yeah, I'm trying to drag it. Hold on. Wait, I have to drag a little bit more. But now I cannot see it. So now I don't know what I am.
You want to mirror it with this part or just?
Yeah, well, I think, am I getting there?
Oh, there you go. Help her out, are we at the big one yet? No, the maximize, it's.
You can look over here.
There we go, yeah.
The middle button will do it.
It doesn't do it. Oh, there. Okay, yeah. Well, but now I cannot see here. Okay, so I have to look on this side. Can you hear me? Let's see. All right, so, okay, so this is, well, okay, so this is the entry for the school. So you are able, here we're able to see all the faculty members that we created entries for. So we have the list of faculty members, their birthdays, if we find them in their VF record, ORCID IDs. I can scroll down, I don't know why, I'm trying. Yeah, okay. Then it gives us a co-author graph, advisor graphs, recent publications. So this would be for the school as a whole. And then if we go back and we use Una Auxili as an example again, then we can see all her publications, the date when it was published, the type of work, the number of pages, the publisher, the journal where the work was published, and the authors. And then we get a number of publications per year, and this is all color-coded, so you can actually see her role in that publication, whether she was a first author, last author, or middle, no, solo author, yeah. And then the number of pages, which is the reason why we were entering that manually, so you can actually get the stacks of how many pages this faculty member created for each particular work. And then the journals. Oh, and for all these graphs, you can actually, oh, this is hard to see, but you can actually change the display in any way you want here. I don't know if this would make sense for, no, it's not gonna be that effective, but you can, and yeah, the point is that you can actually change it. And then we have the author graph. You can, if you double click, it will take you to the Wikidata item. If you just click once, it will get all the different properties. What else? Subjects for that paper, then a table for the subjects, associated images for that faculty member. I'm not sure what we can do with this, but I think it's kind of cool. And then a timeline for the education and employer. This one is not loading, but you get the idea. So we have all that information and citations, which I want to go back and show you very quickly for one of her works. So here we can see the graph for the topics, and then there is a list of all the citations to her work, and a list of the cited works, and a citation graph, which I think is pretty interesting. It has the name of the author and the year where the work was published. And then, yeah. So, I mean, it's a lot of work to get to this point, but I think there's a lot of value in actually doing this kind of work. And so Jerry now is, Jerry's gonna talk about the outcomes of the project and why we're actually taking the time and putting effort into doing this.
Yes, so this was 8,000 edits, a little more than 8,000 edits. And my primary contribution to the project was entering data and messing up several times. And my release had to go in and replace data that I duplicated. So that was a learning curve for me. So as you saw, we created entries for 17 faculty members. One had already been created. And we indexed, I suppose, 110 publications as well. But why did we do this, and why are we doing this? I'm a scholarly communications librarian, and the number one reason we did this is that we thought it was fun, and we like Wikipedia, we like Wikidata, so hey, and like I said, we work at a place that kind of rewards people doing stuff that they think is fun, so that's probably the real reason that we did it. But also, we work, those of us at universities now, we work in a world where we own a lot of data and give it away, and we give it to companies that then sell it back to us at a very steep price with reuse limitations, or sometimes, no real access other than the provider's website and the way they want to display the data to you. And we've been doing that for quite a while. And we're doing that now in a marketplace where a few companies are not only buying our digital repositories, but also buying up software all along the scholarly communications pipeline, from, the reference management software to the repository and other things, all the way to the evaluation tools and the data about that literature. So even if we were, in my dreams, to kind of win the open access battle, we might lose the data battle about that open access material. It's kind of no longer just about the article, it's about the data about those works. And this is a little pushback for us, a little pilot pushback to say, can the community do it? Can we own our data, curate it, and display it? So what could be next for us? We, at IUPUI, we host 15 journals on OJS. That's a lot of data. I think we have 17,000 articles. We could contribute all that to Wikidata if we can get past the labor load, and maybe some of you guys can help. And we also have a lot of other collections and data about those collections, as well as some of the data that was discussed in the presentation before ours. We think all of that might be able to find a home in a place like Wikidata. But as we've said a few times, this is a lot of work right now. We think there are ways to reduce it. And if I'm trying to sell Wikidata to the School of Philanthropy, they're going to have some hesitations about it, partly because Una, whose profile we saw, isn't actually complete, and she won't be happy with it until it is. And it won't be complete until all of us become contributors. And I kind of have that same problem when I'm talking to librarians about this tool, sadly. So in spite of all that, I still believe this is something we can do. And I think there are a lot of people in this room that are probably already working on it. And some of the presentations that we saw, which really described reducing sort of the barrier to making data reusable. And I'm hoping that some of you will get in touch with us with some ideas for how we can make the labor a little less expensive. So I'll stop with that. What? 2.5 minutes.
So if you want to take some questions, and before that, I'm going to put the lightning talk list up. So folks, if you're in a lightning talk, start coming to the front. Can you go ahead and mirror the screens again? Sorry. All right, do we have questions for this fantastic presentation? Oh, come on, Windows. No questions? There we go. Thank you.
Hi. You said you have a tool for collecting the citations and publishing them into Wikidata. Can you talk a little bit more about that tool? Is it something you built? We do a much more modest sort of collection approach and find it to be a pain, so I want to know what you're doing. Thanks.
We didn't build any tools. The tools are available. There are a lot of third-party tools for getting data into Wikidata, including tools that will, leverage what you have in Zotero and things like that. I think the limitation with those tools right now are that there's still a good deal of manual, like item-by-item repair work that has to be done. So when we were using the source metadata tool to get articles in, you still had to go and create an entry for the journal. Like it didn't automatically pull the journal out of the Crossref data set. Things like that, that's some development area that some work that needs to be done.
All right, on that note of work needing to be done, that was a great presentation. Another round of applause. Okay, so we're going into our lightning talks round. We've got 9 speakers, and y'all are going to speak 5 minutes each. I'm going to be here hovering behind you, about to kick you off if you go over 5 minutes. Our first speaker, we've got Declan Fleming with Serendipitous Browsing with VP. VR. VPR.
It's all about bad handwriting. Aaron, would you put my movie? Sweet. So, I'm a director. I don't actually do anything. Thank you. Hey, you're welcome. Which is a good thing. Ah, for goodness sake. Oh, I see. Oh, it's playing. Don't play yet. Stop. Is it playing? So, one of my old bosses asked me for a while ago, and being an old person as well, I enjoy serendipitous browsing, going through the stacks and seeing what's there and what's possible to see. And a lot of electronic resources have taken that away from us. The catalog stuff, you get a link, you get it, you go walk to the shelf, you pull it out, or you have a call to get it. So I wanted to see what's possible to do with recreating some of that. So I went and paid a kid named Jean-Luc Thum to build me a little library in VR. Having played some games and stuff, I wanted to see, I can't see it on here, so I watch while he's doing it. So this is basically a bookshelf, a virtual bookshelf that he can slide back and forth this way. We went and dumped the catalog into a database because he didn't know. He tried to do Z. Roy, what's the standard for getting stuff from the catalog? Yeah, thanks. I figured you'd know. Z3950. It's a little too slow to actually feed all these books here. One of the things you'll notice too, as we look at the different pieces and parts, resolution on VR right now is pretty bad. So getting enough actual. Oh, here I can see it here. Getting enough characters into the spine was very difficult. So one thing I had him do just recently, as he puts the hand closer, they scroll, which is a little creepy, but. It was great when he first showed it to me because they were all. First, I had him put colors on the books. This is totally a prototype. It's not even a prototype. It's just a bad idea I had. And as a director, I get a little bit of budget to throw at students, but he's learned a lot. This is all done in Unity. It's all just a typical game engine, but I believe it's free, at least for academic use. And he's just been kind of going nuts with it. He's using not Vive, the other one, Oculus Rift on this. I've got a Vive, so I can't play with it at home just yet, but we're working on that, making that all happen. So it's a prototype to see what does it feel like to actually work it in an environment like this. So looking at titles is very difficult, and so we played around with actually how can we fit more on the spine, and well, scrolling is what we did here. Look at this, boop. So you can kind of, oh, that was kind of cool. I spend 5 minutes a week with this guy, and he just kind of does stuff. Then he was like, okay, what do I actually do with the book? How will I want to interact with this? And blop, it goes in there, and then you get the card. So I've reinvented basically Roy's childhood. But the idea is once somebody has the object, you can do all kinds of stuff with it. It could have this cover art. It could have links to other things, whatever. This room that we're in right now is just a map of our digital media lab, sort of our makerspace at UCSD. And but this is a virtual thing, so we can have a big screen pops up and shows some things there. I wish the statistics thing wasn't up there on the screen. That just came from recording, so. There we go, and then look what you can do. Isn't that awesome? And now, just the same idea. He just scrolled down to another bookshelf, and you can go back and forth as much as you want. Again, looking at the title, blop, and then there you go. There's the information there. And then I said just play with the physics a little bit and see what's possible to do. So that table behind that you put the book onto, that could be like a shopping cart concept or a book cart even to get people thinking about that. So you could gather things up, maybe hit a save button so it's always there when they come back. Or they can take it and mess up all the other books with it. It's so freaking cool. And it's got physics too. They have weight, so you feel it in your hands like. Blah, 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 blah. This kid's not a library student either. Yeah, doesn't it? It gives you. It freaks even virtually. It freaks me out. They treat books like this. Anyway, so I thought that was kind of cool, and it's all in GitHub. Anybody wants to play with it? His name is Jean-Luc Thum, and he's doing really neat stuff. I don't know what I'm going to do with it. It's just, the old boss had bothered me for quite some time about how do you remember the Harvard thing, you can do the serendipitous browsing with the stacks of book this way? This just felt a little more intuitive. Definitely limitations with the resolution. And I've just grabbed an old concept of having just a bookshelf in front of you just to get started. But what do you do with them? Like we're thinking if we take away gravity, you can like set them up around you to float around so you can go back and get back to them. And then Matt Zumwalt has some really excellent ideas about mixing this into your whole environment, like your pictures and your emails and things like that. Sorry, Matt, I don't mean to steal your stuff, but it's kind of a neat thing, so hope you like it.
All right. Thank you, Declan. So now we have our next speaker, Jason Clark, on algorithmic awareness and digital literacy. All right.
Yeah. So it's in the OSF. Let's see. I might just have somebody else go while we're trying to get this, because I don't want to waste too much time.
All right. Got it up here. Did you download it?
No. I'll have to go. Bring somebody else up. Okay.
Well, do you want, you have it with you or now? No?
Not on me. I'll go get it.
Okay.
Okay.
We're putting you down to the bottom. All right, so just kidding. We're going to have now Kurt Nordstrom. Yeah. Folio under the hood. And you, yep. You're all good. How are you doing?
So where do I pull this up? Let's see. Can I just pull this up on the web?
Yeah. Should be able to.
Where's the browser window?
Now, let's see. Try to get Firefox.
Oh, there it is. No.
You got it?
No, no.
No. All right, come on. Is it coming up for us up there? Yes. Okay, so we've got a browser. That's good.
There it is.
And then, can you get it in there?
How do I get it?
This is just the URL if you've got it online, or.
I mean, how do I maximize the?
Well, this is just someone else's file. Do you want to? What?
Sorry.
What are you trying to do?
We're trying to pull up the presentation in the web browser, correct?
Right.
Yes. And it's still, yeah. Lord, if it asks us to install a security update at this point, I'm going to just like All right.
All right, am I good to
all
go?
of that fanfare.
Okay. So hopefully that wasn't the most important, most interesting part of the presentation. All right, so my name is Kurt Nordstrom. I am a developer with Index Data. There's my email address. I primarily have been doing back-end module development with Folio, and my colleague Peter did a 15-minute talk yesterday about just an overview of Folio. There were a few questions that came up on kind of the back channel about some of the technical details, so I just kind of wanted to dip into a few of those. Hopefully this is useful to somebody, and if there's something that seems interesting or you want me to come back to, by all means, grab me. This is the scariest part of my job, talking to human beings, so I'm doing my best here. So just a really quick, broad overview. Folio is an open source library services platform. It's microservices inspired. We won't make the claim that it's actual, really canonical microservices, but we do take a lot of ideas from there. But what I want to talk about is Okapi. Okapi is our API gateway. That is the pattern that we follow to have all these microservices talk to each other. Kind of got its name from the OK API, and we also have a thing in index data about stripy mascots. If you remember our zebra indexer from way back in the day. There were some questions about what do we build our stuff in. So we have built Okapi, and several of our core modules are in Java. We use the Vertex toolkit, which is a reactive, asynchronous web toolkit. But the truth of the matter is that these things don't really matter very much to the Folio developer. We've chosen these tools for kind of internal consistency. We do have a number of utilities that we have built that facilitate building modules in Vertex, but nobody is required to use these, and Okapi is happy to work with something that's not built on Java or anything like that. Everything communicates through the HTTP layer, so there's no hard requirements for running on the JVM or anything like that. Just in case that was a question. So the only just like Solar runs as a web service, so does Okapi. So within Folio, everything goes in and out of Okapi. Nothing talks directly to another service. Everything has to talk through Okapi, and this allows Okapi to serve as the gatekeeper. It is able to enforce permissions, it's able to check credentials, it's able to do whatever other kind of filters we want to put on it. If we want to do like logging or some kind of traffic filtering, we can do that at the Okapi level. And because Okapi is the central point of truth, we're able to affect everything that goes in and out of the system. So Okapi is a web service, and all the modules are just web services. So just a quick look at how do they talk to each other, how do they relate to each other. So I was going to put like an example of what a module descriptor looks like, but then I realized that I'd be making people look at JSON, and that's not cool. But it's a JSON structure, and the pieces of information that are important to have in your module descriptor, it needs to have the unique ID of the module. The module have a name of a module. It needs to list the number of all the exposed endpoints that module uses need to be in this descriptor, and also the permissions that are going to be required to access these endpoints. And then also within the descriptor, you're going to also define the permissions that this module uses. So for like users, you might have user read or user read list to get like a list of users, user to modify users, that kind of thing. So this will all be listed in the module descriptor that will show you, that tells Okapi what this module can do and how it's identified. But the next step is so you'll put this in a JSON structure. You just post that to Okapi through its administrative interface. And then you need to actually tell Okapi where it's going to, how it's going to get a running instance of this descriptor. So you'll have a second little JSON structure, which is going to have the module ID that's going to correspond with what you had in your module descriptor, the node ID, which if you're running just like a single thing of Okapi, just your local host, and then also launch descriptor telling it how it's going to actually start this instance, be it a URL or on the system or Docker. And then once that happens, you have your running thing, and you can access your module directly through Okapi, which is now acting as the proxy for that module, and other modules can talk to Okapi to get to that module as well. Finally, places to go to get more information. Talk to me, email me, try to corner me. Also, you can get our Vagrant bosses to play with, and also check out the Okapi guide, which is a really great walkthrough for everything. Thank you very much.
All right, thank you. Okay, so Jessica Wu. Oh my goodness, the split screen is going to be the death of me.
But it's okay, I brought it back up.
Yeah, there we go. There you go. Yeah.
Okay, one moment. Okay, let me pull it up. I had a backup for not having a note sheet. So I'm gonna precariously set this up here. All right. Okay, all right. Oh my goodness, the timer's already started. So I'm Jessica Wu. I'm a web librarian at Vancouver Public Library, and I'm here to talk about user consultation and user testing of library services, products, or tools, and to kind of prompt us all with 3 considerations when we do this. So let's start. Okay, I'm going to assume, let's all assume that you want to adopt a user-centered, user-centered design. You know that hearing from your users, directly consulting with them, means that you're going to make your service or product or tool more human and more empathetic. And it's going to benefit your users, it's going to benefit your business or library, institution, and it's just going to benefit you because you're going to create something awesome. Let's assume that you know how, or you have an idea of how you might go about doing this. These are some of the methods that VPL has been doing over the past 3 years, ranging from really quick surveys that kind of pop up when you're on the library website to actually doing formal interview sessions with users. And you're ready to go, but wait. Before you launch that survey and before you set out your testing table at your library, let's think about who you're getting feedback from, whose voices you're actually hearing, and better yet, who are you not getting feedback from, whose voices are not coming out loud and clear. So learning from other Code4Lib speakers, photos of animals in your slide deck equals delight for everyone, which is why I inserted this, and also a subtle kind of Canadian pride showing with the Canadian geese. Okay, first consideration. How do you hear from people who don't currently use your library or service? So ways to kind of include this in your gathering user feedback is set this out in your scope, that you're going to target or make sure you have a certain percentage of users that you're gathering feedback from are users who are new to your service or don't use it. You want to ask and recruit intentionally and choose the right setting, not just in the library that you're testing, but at the student union building or, like outside of the library building. So we've done that at the public library. Okay, how are you hearing from people who don't speak English as their first language, or people with different cultural expectations or understanding? And my experience doing multicultural user testing was very interesting. I'm running out of time, so come talk to me at the reception or wherever, and I can share some pretty funny stories and interesting takeaways. And you can find these slides later, so I'm not going to go through each point. But what I thought was interesting, I didn't think about this, was designing our incentives that if you're giving a gift card to, say, a coffee shop, you might be user testing with a cultural group that doesn't go to coffee shops. They don't go to Starbucks. And so, for example, with the monolingual Chinese community in Vancouver, we thought about this beforehand, and instead we gave out T&T supermarket gift cards, and they loved it, and it was great. And if you don't know what T&T is, you can look it up. Or talk to me. Okay, and then lastly, users with accessibility needs. So how do you hear from people who use assistive technologies or have accessibility needs? And I loved Kate's workshop on ARIA web accessibility and our breakout group discussion about it. And come talk to me about this, because we've also had experience of actually working with our accessible services department to recruit intentionally, having sit-down sessions with people that were using assistive technologies. And it's a whole other ballgame, because you're going to have to think about, are you in the right setting? So something like asking them to come in, that might not be possible. So you're going to have to adapt and do things like suggest going to their home, meeting them where they are, where they're using their assistive technology. And then also just one more note, whoever's wearing glasses here, put up your hand. You are using an assistive technology because of your glasses. So if you want to test, guess what? Just take off your glasses and pull up your phone, use VoiceOver or whatever, and you're actually going to get that experience. And I think that's something that we kind of gloss over, we don't think about. That, hey, we're a user too, and we can actually provide that perspective and feedback. All right, so email me, find me on Slack. Thank you.
All right, fantastic. So next up, we have someone talking about automating circulation notices in Voyager. Yes, there you are. I'm sorry, you have to. It's all right, we didn't lose the title.
Let's see. Now the question is, where's the PowerPoint?
Let's get rid of this.
Should be a file named AutoCirc.
So that's not up. Let's get the files up. There it is.
Thank
All
you.
right. And the presentation's right here.
Okay. Thank you. Okay, so my name is Bruce Orcutt. Second time here at Code4Lib, first time attempting a presentation. And contact information's there. I'm with the University of Texas at San Antonio Libraries. And basically the problem that I wanted to solve was Ex Libris's Voyager out of the box to send circulation notices. A staff member needs to actually manually run a thick client app, and it then downloads all the notice information down to their PC. Then they have to take several manual actions before notices all go out. So what happens, like, if a staff member forgets to do it, or the person, all the people who know how to do this process aren't in that day, or if there's a break, a holiday or the like, no overdue notices, fine notices, etc. go out at all if in those cases. So it came to a point like, okay, this such a manual process, such a big chance of breaking, is there a way to automate this? So we first noticed all the notice information is stored every day in a plain text file that's fully accessible if you have shell access to your Voyager instance. And the file format is also in the technical reference PDF that's given to you by Ex Libris. So it tells you exactly which field does what. So basically, wrote a Python script that will take the notices file line by line for any patron that has an email address on file. It will combine all their various notices of the same type, so multiple items overdue, one email, multiple fines due, one email will sum the fine, etc., and send the email directly to them. Some of your patrons may not have an email address on file, but at least at our location, all of them have at least a postal address. So the program automatically makes an RTF document so access services people can print out the document easily in Microsoft Word or the like. And then with the postal address on it, they can send through US mail the fine notices and the like to the patrons. And then, since we're already gathering the fine fee collection information for that day, added another wrinkle based on what access services wanted, to say, hey, let's go ahead and do a simple database query and grab like the historical, find information for that, see if they owe a whole lot, so they can prioritize collection efforts if need be. And two, if anybody wants to run this, the configuration is pretty simple. Almost all the config information that you need is just in its own this automatically include Python file that's pretty much just a list of variables that is descriptive as possible variable names like, okay, email address to come for notices to come from, blank. Who do you want the printable documents to go to, blank, etc. And then this is available on GitHub at the link provided there. And +2, I am on Slack or the Code4Lib IRC. On IRC and Pervany on Slack, BA Orcut. So yeah, I encourage anyone who likes the code to feel free, grab a copy. And you'll be glad for others to run it. We really found it's helped. Like after we got, it took like maybe a week of working out the kinks, but after that, it's been just configure and forget, and it's greatly improved the process for things for us.
All right, great. So next we have, let's see here, Esme Cowles talking about emoji curation. Do you have PowerPoint or?
PowerPoint. Let's see if I can just.
Cool.
Hi, I'm Esme Cowles, and I had a little bit of trouble deciding what I wanted to talk about. I've been a part of a lot of cool work in the Samvera community. I'm a Fedora API spec editor. We've been doing a lot of cool stuff at Princeton. Check out Figgy and PullMap in particular. We've had some good success with those. But I decided to present on emoji curation instead, despite the movie. Because I think that fun is an important thing. Like art, if you don't know the Cheap Art Manifesto, I highly recommend you look it up. The key line here is that art and fun, you can't eat it, but it feeds you. It feeds your soul. And so I think that play and fun are an important part of our lives. And so as we go through our lives, we spend a lot of time talking to each other on Slack and GitHub commits and other things that are, you know, pretty cold and impersonal. I think it's really important to be able to say things like, hey, I hope that Travis run is successful and we finally got that problem fixed. Or, hey, yeah, I got that. I merged your PR and it's all good. And, you know, it's important to be able to commiserate. You know, sometimes things are bad. I mean, really, really bad. But I also think that there's times where a lot of the systems we have things built in that we don't like, that don't exactly reflect the way we want to do things, and it's important to be able to, you know, customize things a little bit, put your own flair on things, you know, fix some of the small things that are bugging you. I think it's great to have a visual vocabulary for the projects that you're working on that are obviously not going to be included in sort of the default emoji. I think it's great to have a naming system and name your products whatever you want and make a visual vocabulary for those too so that you can talk about them, refer to them, use them as your status in Slack, whatever. But I mean, curation is a fancy word, but what I'm talking about here is really not rocket science. What I'm talking about is, you know, going to Google image search and finding a good picture. Resolution is not important, or I guess it is. It has to be low, and so that makes it a lot easier to find good things. You know, you can crop things with your regular image editors that probably come with your operating system. Tools like Slack and Link, and I know lots of others, let you set your own emoji and add your own things, and that's not hard to do either. It's really, you know, the practice of doing it, using them. You know, I realized we didn't have a Code4Lib emoji in our Slack channel, and I wanted to set my status, so I just went and grabbed one while I was writing this talk and thinking about it. so that I could set my status to say, hey, I'm at Code4Lib, guys. Thank you.
All right. Thank you, Esme. I hope everyone's making emojis now and putting them in the Slack. Now we have Stephen Gaines. Up. On the website. Okay. Let's go. Oops. That's file. On the OSF site?
Code4Lib.
Oh, sorry. Can you, go ahead.
Yeah, that's all right. What is this? Oh. Getting used to the click, sorry.
It's all right. There we go.
Probably had to download it.
All right, who's also streaming on the network while we're trying to run this?
Wow, yeah. Streaming, FaceTime. What else we got going on?
Scroll down.
That's crazy. Yeah. Here, I'll let you drive it. I'm not familiar with that.
All right, what are we looking for?
Poor man's VDI.
Poor man's VDI.
Yep, right there.
Right here.
Yep. And PowerPoint already? I put
We'll
three
find out.
I put 3 different ones.
Oh, thank you.
Yes, thank you.
So,
I got a PowerPoint?
This guy.
Yeah. Would that download it or just open it in?
We'll find out. Thanks, Ashley. All right.
Should we download it, though, just because of the delay and the...
Download.
Yeah, well, that's a good idea.
All right, we can do this.
That'll work.
Yep, okay.
And... Sorry.
Nope, right here. You can just hit that, this guy. Presenting?
Okay. Just make sure. Beautiful. Okay. All right. So my name's Stephen Gaines with the North Country Library System in upstate New York. I can got my email there, sgaines@ncos.org. We're a public library system in New York. We have 65 chartered libraries. There's 3 of us in IT. We take care of their iOS, their websites, their email, and everything. Desktop solution, 700 desktops in the libraries. We manage all of them. We buy them. We set them up. Everything. Right now, we're migrating towards Windows 10 from Windows 7. With Windows 10, the amount of time we have to put in support, just updating alone, because we're public PCs, need to lock them down. Locking them down is work with updates. So, we've really got a conundrum here and a problem. So I tried to look at alternate solutions, and this is what I come up with. Okay, so your basic desktop has a PC, a Mac, whatever it may be, with a hard drive with the OS loaded, applications, peripherals, all the processing is done locally. Endpoint can run you 600 or 700 hours. Your maintenance cost is your big thing because you have to keep these updated and supported. You update the software and update the OS when that's due. So what's VDI? Virtualized Desktop Infrastructure. So you have these super servers with host images of operating systems, maybe Windows, maybe something else. The endpoint runs like an RDP client or a remote FX client. So you're really just getting the visual from that image. All the processing is done on the server. On the endpoint, you're just kind of like seeing it and interacting with your keystrokes and such. There are proprietary solutions out there, VMware, Citrix, others. I know one system that happened to pay $700,000 just in licensing for 1,000 endpoints. So, and we can't touch that. That's our budget that's our IT budget for a decade. So, okay, so poor man's VDI. All right, and this is kind of a framework, a kind of a mashup. In the summary, I'm using a diskless endpoint with no hard drive. It PXE boots. It installs the operating system in the memory. from one of the LTSP servers I'll talk about in a second. The management of the devices is done with a small Linux program that runs when the user logs in or when the image logs in automatically. During the boot, only the Linux kernel and the initial RAM are downloaded from the server. The file system, the rest of it, several gig, is mounted as an MBD share. So any further communication between the client and the MBD server occurs when you need to launch a browser or a program. Okay, so here's the framework, the components, PXE, open source boot firmware on the network card, Linux, LTSP, which is a Linux terminal server project, and Drupal. PXE, you need to have your option packets in your DHP server to know where the boot server is and the kernel location. When it boots up, I have it chain, and this is where I tell it which image server to load from and which image to load and how to mount the MBD share. The kernel tells the web path, and it's all only read-only. So with no hard drive, your entire file system is loaded as a squash file system in RAM. So it's extremely fast once this thing boots up. The Linux Terminal Server project allows you to create the images. Again, I'm not going to reiterate some of the points there. So to control this, I'm using Drupal on the back end. It's open source. You can create content types to store anything you need to manage these, libraries, workstation types, etc., printers, printer modules. You can create a printer model and link the PPB file and just have that exposed on your web server so you can download it when you need it. You set permissions so that all of these libraries can manage their own instances. The content types allow for you to create and store various data and even future things you want to create. RESTful services in Drupal allows the CRUD, create, read, update, delete. So the client interacts with the server. It creates a record for itself. You can also use rules in Drupal to manage the back end, things that go on behind the scenes. So when you update a record, it'll go in behind the scene and update the config file for the TFTP. The client program, when it boots up and loads, it starts and it talks to the web server and it creates a record for itself. It'll install a printer if there's a printer there to be installed on the web server, updates the record with timestamps. It's all controlled by the MAC address, practical uses, OPAC, self-check, digital signage, public workstation, staff. Hopefully I want to eliminate Windows in the library. Advantages over no licensing costs, inexpensive, I'm using $150 endpoints. Process is all done on the clients, no need for super servers. Updates are done nightly, images created nightly, endpoint gets a new image upon reboot, and if I want to make that an OPAC and turn it into something else, I change it on the website and reboot it. Now it knows to be something else. That's it. Oh, yeah. Thank you, and live long and prosper.
Thanks for that. It's nice to be having so many advantages that you run out of time saying them. So we have now David Tinnenholtz. Yep, ready to go? Do you have your...
It's on the desktop.
Cool.
Shortcut PowerPoint presentation there.
Desktop. And...
It should have my last name as the file name.
There it goes.
There it is. Thank you. Thank you very much.
No problem, Bob. All right.
Hi, everyone. I'm David Tinnenholtz. I'm the digital archivist at the RAND Corporation. There we go. And prior to that, last year was my first Code4Lib, and I was a grad student at University of North Carolina at their library school. Prior to that, I was a music library associate at the University of Richmond. And prior to that, I played piano at Busch Gardens. So, hashtag lifelong learning. And so I'm here to talk to you about some work that I'm doing with legacy media. These are floppy disks from the 80s and 90s, and they are damaged. So I want to actually talk to you about who they belong to first. Willis Ware, it is really not a good idea to summarize all of Willis Ware's career on one slide. You should really check out his New York Times obit or the one, there's some information from the Institute for Advanced Study at Princeton where he got his start. He had a long career at RAND, and he touched on so many different things. It's safe to say that we, as users of any system, are benefiting from Willis Ware's work. So In his collection, it's a lot of different stuff, including 2 boxes of floppy disks. They're all 5¼ inch floppy disks. It's about 300 of them. They are 500 kilobytes in size, unformatted, and most of them are formatted to be MS-DOS formatted, and that closes it off at 360 kilobytes. So there's not a lot on each disk, and typically it's information that is zipped up. They were in his garage in Santa Monica, California for many years. They were exposed to the elements, and when you open up these boxes, the stench of mold just sort of comes right at you. So in order to kind of get at this collection in some sort of pipeline or workflow, before I joined RAND, the head of archive services there put a score on each box, individual box of 3 or 6 or 10 disks. Each box effectively was then sort of graded so that we could start with the ones that were least problematic and work from there. Some of this hardware and software might be a little bit niche, so I can just sort of get at this really quickly, but please do email me, and if you want some further details, I'm really happy to share that stuff. Hardware-wise, if I can sort of abstract from here, you need a floppy disk controller, you need floppy disk drives, we have 2 of those, and then you need a workstation. So in our case, we're using a forensic recovery of evidence device workstation from Digital Intelligence, and you're certainly going to be able to get by if you were to use some other type of workstation that can be Windows-based, a Windows-based PC. Software-wise, we're using the software that came with the floppy disk controller, the FC5025 controller from Device Side Data. And that is a GUI app. It just works. It allows you just to be able to select the type of format of the disk that you need, create the file path where the resulting image file will go as you're doing the forensic capture, and it allows you also to, rather than do a capture, it allows you to browse a disk rather than actually reading or imaging it. Then we just need a spreadsheet to track our processing as we're going through it, and since at each time as I'm doing an image run of a single disk, I actually get a lot of information as to if it takes a long time, I use a stopwatch. So I'm tracking everything that I'm doing with a stopwatch. And the free stopwatch app that was a Windows app that allows you to just copy paste times into a spreadsheet was really nice. So past that, there's some pretty ubiquitous supplies, nitrile gloves, lens cleaner that you can just make by yourself, cotton swabs. We do have the luxury of having a fume hood in our archives where I'm working, and that's where I do a lot of the spraying of lens cleaner and stuff so it doesn't affect others. So our strategy to get at this, we've done about 100 disks this way. We clean the drive with this floppy clean disk napkin that you sort of insert and it spins, and then you sort of trust that it's worked. It's not a bad way to do it, it's just that oftentimes you're still going to run into issues, and I can talk about that at another time. Typically what happens with these disks is the top layer of a floppy disk is iron oxide. It's the black top layer, and that through like shearing force of the drive heads and other things, it will flake the iron oxide off onto the drive heads of the floppy drive. Am I running out of time already? 3 seconds. Here we go. You get really bad data. This is actually an image file from Willis Ware. That's the best I could do on that one and that one. What I did was I used John Durno's article. I cracked open the floppy disk. It looked like that. It was really bad. And the result was, after cleaning it and putting it in a fresh case, I was able to get at that. So that was fun. Thanks a lot. Sorry it was a little short. Thanks.
All right. Okay, so next we have Elizabeth Mumpower, GitHub for small teams. And you have Okay, yep.
Right here.
Oh, hold on, let's make sure this is going in.
Yeah.
Let's go, this guy, come on, screen. There we go.
Okay.
Now we can go.
Yeah. Okay. And then. Okay. There we go. Okay. So my talk's on GitHub for small teams, or making small teams more efficient. This talk came about because I'm at Emory University, I'm a systems librarian, and we embarked on a project to install or run EasyParse, which is a log parser for easy proxy logs. But we didn't just want to, run our logs through it. We also wanted to make sure we were de-identifying. We wanted to make sure we were also pulling in a lot of registrar data and demographic data. And so it was working with a lot of different stakeholders and a lot of different IT organizations on campus. So why did we choose GitHub for project management, basically? Is the landscape before is for a lot of big projects, we were working with a project management office. And so they had their own like Microsoft Office project. They had their own sort of tools. They would sort of put things in different places. But as far as working within our own team and working with stakeholders ourselves, we hadn't really done anything that would collate all that data into one spot. So starting out, we were already trying to use GitHub for our code. We were like, why don't we try, some of the features in it, and we can keep our code and our timelines together. This was also a small team. There were 3 to 4 of us that have worked actively on the project, not including stakeholders. And the project that we were going to end up working with was also open source, so it allowed us to, get into the GitHub ecosystem, fork their project, work with it more easily. And so from here, I'm going to talk about how we did it, benefits for the team and benefits for the subject matter expert stakeholders. So how we did it initially is we had 2 GitHub projects, or repos. We had one for implementation, and it was more admin level items, and it's a private repo because some stuff's in it that we don't want public. And then we had the one for the EasyParse platforms themselves, which are the parsers that actually go through the EasyProxy log data. And that's public, and it's forked from an official repo, and it's in the notes for this presentation. In GitHub, GitHub repos have a project thing that you can use that's like a Trello board setup. And so we did that. And we did, the to-do, in progress, done, parking lot. And we put all of our work in there, not just code. If I had to ask for a server, it was in there. If I had to ask for something to be installed, it was in there. Any tweaks we made went in there as issues and then went in as cards into this project. We also had a Slack integration so that we could keep updated if things were added. And then I also referenced the issues and weekly updates that went to our executive sponsor. At this point, we were also able to establish rules as far as pull requests and things like that, like don't close your own pull request, here are guidelines for checking. This is what it initially, the private repo looked like for a while. And as you can see, it's not just code. Like we have download and set up Tableau, production-ready transfer of data, things like that. And any notes that we may have had as far as there was a problem here, our sysadmin said we couldn't do this, it's all in those issues. So how are we doing it ongoing? We're mainly working with the platform, so with the public repo now. And we're measuring progress with 4-week intervals, which are still projects in GitHub. And it's sort of trying to work with it like a sprint, where we see how much we can get done, and then we're tracking our progress to better understand our work capabilities or velocity moving forward. We're also able to get buy-in from our subject matter experts because they can easily see what we've worked on, what we're running into problems with, things like that. So the benefits for the team are that all of our information's in one spot. I'm not having to send people to Box, to Wiki, to Slack, to some other random content management system. It's all there for what they need. It's been a learning experience. Our team was trying to use GitHub for code, but it had been sort of an ongoing process. There hasn't really been a project that was introducing using pull requests and reviewing and accepting and merging on a daily basis, and this has worked really well for us. And this has also given us the ability to more readily contribute both internally and externally. Not only has it been a learning experience for our team internally, but it's also given some of the members the ability to contribute to open source projects externally because now they feel more comfortable doing pull requests against forked repos. It's also a better understanding of open source because they're getting in a deep dive into the project. And its benefits for subject matter experts, there's transparency about team progress. While they can still ask us what we're doing, it's all there, they can see it. There's also visual evidence of their input because we can make issues, they can make issues if they want to. And so the takeaway is that for small teams, GitHub can be a beneficial project management tool, not just code or versioning. It can be team building as well. And a smaller, more low-key project can also serve as a great introduction to GitHub and or open source, and transparency is provided as a benefit for stakeholders. Thank you. There's my contact information.
Great, fantastic. So, Megan Ferreter, LT Labs.
Thanks. Woo. I was promised heckling, so that's good. May. Well, my name is Megan.
Got it.
Yeah. Hopefully. Loading. My name is Megan. I'm part of the Library of Congress Labs team, known internally as National Digital Initiatives at the Library of Congress. I joined the team 6 months ago. This is my first Code4Lib as well. I always watched from afar previously. And I joined the team at the time it was led by Kate Sward and rounded out by Jamie Mears and our current chief, Abby Potter. And chatting with Jamie, I asked, what should I share about our work? And she said, tackle 3 things. I said, okay. But instead of sharing about labs work specifically, I'm going to share some observations that I've made over the last 5 months. I wanted to call this 6 months, 3 things, but it's only been 5 months. We launched labs in September of 2017. So these are my observations, but they also stand out to me because I make qualitative assessments of the kinds of feedback that we're receiving. The first thing is generosity. So from my very first day at the library, my colleagues at the library have been very generous in sharing their time, about their expertise, suggested we connect over coffee, telling me where to find coffee, saying it's okay if I get lost in the tunnels, which I very much appreciated. It's only happened a few times. They've also patiently, very patiently, sat with me and answered questions when I've had concerns or misunderstanding about processes, workflow, organizational culture, tools, programs past and present at the library. Our innovator in residence, J.R. Thorpe, actually has a podcast that showcases this knowledge and generosity, and the staff share with him more about collections, solutions for scale, workflows, and the people and the stories of the library. You can find that on our experiments page if you'd like, or you can search Artist in the Archive. And our work clearly would not be possible without collaboration with our colleagues at the library. And even if someone were to make a liar out of me and say it was possible, the parts that we were doing would not go very far without collaboration. And some of my colleagues from the Office of the Chief Information Officer are here, specifically heckling me. I just want to thank them directly and make sure that the work that they do is visible to others. So thank you, David, John, Tong, Mahibo, Rosie, Chris and Chris, Bill, Jamie, Key, and Laura, Griff, and Sergio, and your colleagues. And also thank you to Library of Congress colleagues here and those who are watching. Before I joined, my colleagues also went around to other cultural heritage institutions, other libraries, other organizations, and asked them about what was working and wasn't working for them in trying to serve audiences trying to access digital collections. We continue to meet with those peers and learn about what they're facing as challenges and what they have as wins, and we're able to take some of those things forward for ourselves when we encounter similar obstacles. It sounds like a very obvious thing, but I can tell you it is not so common for everyone to be so generous. I've been in various sectors where that's not the case, and I very much appreciate the fact that people take their time to share. It allows us to have starting points, to create some hacks, to create solutions along the way. As we launched labs.lsc.gov, we also had no idea what kind of feedback we might receive, and I'm pleased to report we've had both bountiful enthusiasm, collegial support, and very constructive feedback, so please keep that feedback coming. If you've taken time to let us know what we can do to improve, thank you very much. The second thing is contrast. I'm very lucky to be a part of this team. I think we're thoughtful, energetic, experienced, humorous, and we wish to make a difference. And I say those traits as a bit of a mantra and also to combat imposter syndrome. And still we have an approach, we have a productive contrast in the way we approach things. So working together, we talk a lot about how we work, we talk about what we want to do, and especially how we can be better at supporting the people who want to do work with us. Such as our innovators and residents, interns and fellows like Aditya and Charlie who are working with us, and Laura Rubu, who's part of our team during her research leave. And her insider-outsider perspective continues to help us unpack what we're doing more effectively. She also helps us find other contrasts that we can address in the future. Flipping the coin on generosity, that's where feedback and observations come. Again, showing contrasts and the desires that you may have in working with us, that helps us improve and find new opportunities, so please keep that coming. And finally, the third thing is unknowns, or AKA collective fortitude. We face a lot of uncertainty when we've launched things. It's a new experience for some of us to pilot things. It's a new experience for me to pilot things, especially something that needs to be sunset, and find ways to communicate that effectively. And I think what helps us glide across that uncertainty is a bit of collective fortitude and the belief that we're going to be able to improve upon that, improve upon the things that we're doing based on feedback and that generosity mentioned above. So as I pass on to Esther, I just want to ask you to help us identify our own future unknowns. If you want to collaborate with us or give us feedback or try an experiment that maybe we could host, please get in touch with us. You can find us at LC_labs on Twitter, labs.loc.gov, and also NDI@loc.gov, just for a little twist. Thank you.
All right, great. Next we have Esther Jackson.
Wait, please. I'll be right here. I know. Don't leave me. Okay. Oh. Actually, I wanted to refresh it. I don't think I can. Okay. All right. Got it? Cool. I think so. All right. Hi, everybody. I was going to joke that now I'm the only thing standing between you and coffee, but there's one more person after me, so sorry about that. My name is Esther Jackson. This is my first Code4Lib and my first lightning talk. Thank you. Today I'm going to talk to you about Meetup.com and how the communities I have met through the website have helped me develop, pun intended, as a programmer, as a teacher, and as a librarian. So for those who aren't familiar with Meetup.com, or for those of you who would like a refresher, the site is sort of what it sounds like. It is a website that allows people to plan meetups around particular topics or activities. In New York City, where I live, as in many other cities, there is a vibrant and diverse array of tech-related meetups. General study groups exist for many popular programming languages, as do networking events, lectures, and not least of all, workshops. I am not a Meetup.com employee, but I love Meetup.com because Meetup.com, or more accurately, the people who make up Meetup, have changed my life. So a little about me. I'm a public services librarian at the New York Botanical Garden, and what that means is that in addition to being a manager, I'm one of the librarians who works with these. I also sometimes do things like this. And I'm not kidding. But really, I do try to be helpful. And I also put an animal in my slide because of feedback yesterday. I love helping people access information, and not just information in books. However, after I settled into my job, I wanted more. I wanted a challenge. So I decided I wanted to learn how to program, which is a pretty good challenge, as most of you can attest to. So I had no idea where to start, and I went to my first meetup, the League of Women Coders. When I arrived, I had partially completed a W3 Schools tutorial in HTML, so that was about where I was. I was greeted by a group of incredible women who turned me onto better online tutorials, boosted my confidence, and gave me delicious cupcakes, which they do every month for those of you in New York who also love cupcakes. And with that, I was off. For me, meetups have been an oasis. They're an opportunity to learn new things from passionate people. They're a chance to sit in a classroom and learn something, or many somethings, at very reasonable costs, and sometimes that cost is nothing at all. So there are 4 things that Meetup.com has given to me that I'm going to quickly mention. Okay, so the first thing is programming. So thankfully, right, I have achieved my goal of learning at least something about many different things. So I'm not an expert level at any of the technologies you see here, but I've had the chance to take a lot of very, very affordably priced classes. Many of the workshops that I have attended have been through an organization called Girl Develop It. And actually, because of my love of Girl Develop It and the classes that they offer, I signed up to be a TA with the organization. And that leads me to number 2, mentorship and volunteering. It's never too early to mentor. It's never too early to give back. And Meetup's helped me to really get over my uncertainty about doing this. I'm terrified every time I TA a new class, but being terrified doesn't mean I won't be able to help someone. Each time I'm less terrified, and each time I'm a better helper. Helping people learn new things is one of the scariest and most rewarding experiences I have ever had. I liked it before I started going to meetups, but meetups gave me a way to develop my abilities and get even better at helping people learn. Which leads me to teaching. Oh no, I messed up my numbers. Teaching is number 3. For those who teach, I don't teach people math. For those who train and teach in a library or technical setting, you can attest to the fact that the experience is, for the most part, wildly different than teaching or learning in a college classroom. Teaching adults is difficult, and teaching adults practice as opposed to theory is a wholly different ballgame. Like many librarians, I'm a bibliographic instructor, meaning that I teach people how to use things like the library catalog, library databases, and LibGuides, very practical things. I didn't learn how to do this in library school. I didn't receive much on-the-job training, and so meetups and later conferences were the way that I was able to develop this skill set. And at meetups throughout the city, I learned from passionate instructors who were patient, enthusiastic, and dedicated. They took teaching seriously, and many did it very well indeed. However, they were not just teaching classes, they were actively building communities and supporting both new learners and each other. Which brings me to the final slide as I run out of time. Probably the most important thing I've learned from meetup.com and the communities that I've interacted with is community, a valuing of community. Because of these meetups, I've had the confidence to do things like apply for conference scholarships, get outside of my comfort zone, and stand up here today and talk to you about what I've been doing. So thank you very much.
All right. Per earlier, Jason, we're giving you one more chance.
Thank you.
Go ahead and get it up.
How about a round of applause for Christina?
All right. While you're setting that up, I'm going to go ahead and give you guys some announcements. We're going into a break after this, and then we have poster session, which is going to be really exciting. But we will say we have lightning talks tomorrow, Friday as well. So if you want to sign up and enjoy being in front of people while I or someone else is behind you judging your time left, it's fantastic. And you should go sign up by the registration desk. All right, you got it up? Almost? Mm-hmm. You could do it.
Yeah.
All right.
Hi, Code4Lib. Thanks for your patience. Let's see. So I did actually tweet out these slides earlier, but I'm not quite at Matthew Reedsma's wizarding level, so I got lost in the time zone. I'll try to retweet it. I think I was sick that day at Hogwarts. So, I'm going to talk about algorithmic awareness, which is a concept that I've been thinking about for about a year now, really since the election. And so I'm going to talk a little bit about the algorithm itself. I actually put together a grant project around the idea. The reason I'm presenting to all of you today is because I want to show you, or just invite you into the grant and sort of ground it for you. And really, if you think about it, algorithms as we know them are, they have material consequences. So this is an example of, during the Las Vegas shooting, a number of sites identified the wrong individual as the shooter. And it actually got, it was in 4chan, which is a sort of notorious alt-right set of websites. The algorithm was using primacy and recency as important noted factors. Google put out a statement, which basically was, nah, algorithm did it. And so I started to think about, well, what does that mean? We use that a lot, and this is very supplementary to the work that Matthew Riedsma was speaking to this morning. It's usually a ghost, it's something unseen. And I started to think about how a lot of our experiences are mediated by these algorithms, the code, the rules that we embed into our software. And we don't really understand what it is that they do. So I started to ask myself questions like, what if we could introduce new forms of literacy? What if algorithms weren't the ghosts in the machine? And I took as inspiration noted USC scholar Sophia Noble, some critical algorithm studies. A lot of these, again, these links are in the Twitter feed. Again, this is Sophia's book. Please read it. Put those, and one of the opportunities I think we have is to sort of rethink the forms of digital literacy around this concept of what is an algorithm and how would you teach it. So I actually proposed a grant to the LB21, Laura Bush 21st Century Library Program, which I received. And this is it. There's a link to it there. The project itself is mostly focused on a curriculum for a semester-length course on algorithms and algorithmic awareness and a workshop module. There's also a small search prototype that I'm building to sort of annotate what algorithms do as the machine is working. And then we're going to pilot this at various library conferences and venues. An amazing advisory council, Mozilla, San Francisco Public Library, DLF. Really excited about the group that's informing the work. Preliminary work has more been focused, we're in the first quarter of the grant, sort of trying to understand what librarians know about algorithms, how can we learn about them, and really sort of sussing out what is the user experience of algorithms, how things are filtered, how natural language processing happens, all of those things. And then the goal really is to start to introduce this as a new form, if you're familiar with the ACRL framework, maybe there aren't a whole lot of reference librarians probably in the audience, but this idea that there's a new form of digital literacy, and it is actually understanding code, understanding how code works. So our community, our opportunity, and what I'm speaking to you about today is that we, at times, are responsible for the algorithms that we embed. So this is one of our teaching moments. And I'm calling for ways to contribute, for you to think about how you might help this project. So it could be anything from feedback on the curriculum modules, suggested required readings, I've got a GitHub repository. You can contribute to issues in the syllabus or with the teaching software, the prototype. That's the URL. I tweeted it out earlier, but I'll just leave it up there. So if you want to kind of watch what happens with the project. And I would love to have as many voices as possible involved. So reach out, contribute, follow along. I'm Jason from Montana State University.
All right, that was well worth the wait. Thank you, Jason. Okay, so we're going into break now. I know we're a few minutes late, but I do want to say after this, we're going into our first poster sessions. Posters are along the back wall. I've been asked to read out the titles so I can entice you to go check out these awesome posters. We have setting up QA environments on GitHub pull request on the cheap, my library account and the curricular support materials web service, what makes a librarian digital, analyzing linked data from an SEO perspective, interdisciplinary learning on artificial intelligence through libraries, acquiring Twitter data for academic research, head in the cloud or feet in the ground, making preservation, that's a nice one, and Hoot plus Elf plus Folio, awesome borrowing experience for consumer electronics. So those are our posters. We're going into a break now. The break will go till 3:15. And the posters go from 3:15 to 3:35. We start back here with announcements at 3:35. So go get your coffee. So if you're actually here and paying attention, you might be able to get something. Come on back in, take your seat, and let's get this regrouped and started.
Hey y'all, so we still have some really great giveaways. I realized that we didn't actually tell you what they were. There's an Oxygen license, some GitHub stuff, and 1 year of unlimited users and repos from GitHub. There is a 1 year free personal subscription for any JetBrains tool, and there's also digital books from Rosenfeld Media. So great prizes, great giveaways, and let's find out who wins this afternoon. Bhavin Taylor, I apologize if I mispronounced your name. Bhavin? Okay. Andrew Turner? Is Andrew Turner in the room? Okay. This morning, all three of the first name people were here. What would you like?
Not the GitHub.
Okay. Okay, so there's a book, there's Oxygen, and there's JetBrains. Okay, the JetBrains is at the end, and the book is here. Okay, email me for instructions. Okay. All right, our next lucky winner is Matt, KRC. Excellent. Come up and win. Yay. And I'll go ahead and run this one more time for our last winner. Andrew Nagy. Hi. Oxygen, JetBrains, digital book, or GitHub? Yeah. You're welcome. Do you have time? Andrew Nagy, are you in the room? Oh, someone else, sorry. Thanks. Becky. This is not rigged, I promise. Yes. Do you have time for one more? Yeah. All right. And then another one. All right. We still have Oxygen, I think, GitHub, JetBrains, or a book. Okay. Email me for instructions. Nick. And I don't want to butcher your last name. Are you in the room, Nick? Okay. Mark Noble. I heard some cheers. Not here, okay. Another Mark. Different Mark. Mark Bussey. Not here, okay. Anne. Okay. On. Thank you. Delia Golden. Delia? There you are. Okay. Woo! For a little bit there, I felt like I was the teacher in the movie that I can't think of the name of. Thank you, Ferris Bueller. Gosh. Thanks, y'all. All right, you're all good?
Hooray, prizes, or just the chance to figure out who's actually in the room. Yay! All right, we're getting started with our next round of speakers. I'm glad that the poster sessions went really well, but I'm going to ask folks to either take the conversations outside or bring your attention up here to the speakers. And I can ask again more loudly for the people in the back. There we go. I got some eyeballs at least. So our first speakers up after the break. Let me pull up their slides. Hopefully we got a smoother time this time around. All right, so it is Advances in Data Mining and Machine Learning for Chat, Sentiment, and Library Account-Based Recommendations. And speaking will be Jim Hahn and David Ward. All right.
Thank you. Okay. Hello. I'm Jim. That's David. Okay. So this talk really is intended to be an accessible treatment of machine learning and data mining. It is not, well, nerding out about math is really awesome. No math knowledge is required to understand this. I am the type of person who have friends who think that your life is not complete if you have not completed Calc 3. I'm not one of those persons, but I appreciate the sentiment. Some of the outcomes that we see from successful machine learning projects, from our chat sentiment and library account-based recommender was really to gather these hidden user insights to solve problems that may not be practical to solve without machines, like machine learning, and then try to take these user-provided data and expand and provide services over these data mining approaches. And we are going to talk about two different studies. Really, what I'd like to underscore is the methodologies. These two projects used different algorithms, different software packages, but really the commonalities are selecting the appropriate data, and really I can't underscore the significance enough of having enough data to create some of these projects and services. Preparing that data, which is iterative and circular, really. Choosing the right tools, which comes down to software packages, which is really like you don't need the math. You maybe just identify what problem you're trying to solve and identify the right software package, really. So in the case of the account-based recommender, we're using a Weka machine learning package. And then we want to generate some actionable results and create repeatable processes. And I was reading a research article that would recommend research articles, and it was a survey of those articles, and there were about 200 articles that, it was by Beal, it came out in 2016. He found that the field really struggles because people don't share their data, they don't share their algorithms. It's not an open field. It really needs to look to other fields to figure out how to advance. Maybe of those 200 articles, maybe 15 were repeatable. So we thought that was important. So I'm going to move into our account-based recommender service. And what we did was we kind of looked at how there are these vast stores of data that aren't being processed. And if you look at third-party vendors, they're certainly processing user data for their purposes. And what we really wanted to do was leverage these to support serendipity in browsing when you log into your account. And so we created a data stream of subject metadata clusters that are checked out together. And these are some of the goals: really improve account-based browsing, support serendipity. We do have a proof of concept middleware that was developed, and it provides basic personalized recommendations. We're leveraging ViewFind accounts, ViewFind APIs, and also we're customizing APIs as well. So what we did was create a data stream of topic clusters. We use the FP growth algorithm within Weka to generate some consequent subject terms, and we store that in a database. So the machine learning process happened offline, and we grew our consequent subject association rules over time. This project is about 19 months in, and now we have almost 400,000 transactions. So people are still checking out books, and we had clusters to data mine. The next several slides, and I posted a link to Twitter with an actual video of this. I just didn't want to do the video here in real time, but this is an Angular web view, and in this Angular web view, you can log into your ViewFind account at UIUC, see what items you have checked out, and drawing on our database of consequent subject recommenders, we run, there's some business logic that filters recommendations, and then you can click on a recommended item, and you can either request it or see more items like that. As a first step towards assessing the result, we used Splunk Enterprise Analytics software for our logs, and what we found was there are almost 6,000 API events related to users browsing for recommended items. The next step, though, is really we're going to do some qualitative interviews to kind of understand from recommendation users how they like to, what are their preferences and features for using recommender systems. So that concludes the portion of this talk about the account-based recommender, and we're going to turn now to the sentiment analysis of chats.
Hey, everybody. So as we were preparing this, Jim and I were talking about how one of the threads that ties together what we're doing is the importance of methodology and really thinking through how to prepare our data. And that made me think about how there's really two kinds of data scientists. There's those who can extrapolate from incomplete data, and so chat transcripts are something I've worked with quite a bit. By trade, I'm not a programmer, but a reference librarian. And yay, people are great. And we've used chat transcripts for many years as ways to assess the service, both in terms of training and staff improvement, as well as identifying feedback from users that might be present in the data about library services, the website in particular, things like that. So it's been very effective, but it's also very time-consuming. So one of the things I wanted to look into was ways that we could streamline the process or maybe learn more through using some data mining techniques to process the large volume of data that we have. So the goals in preparing the study that I did were to, first off, I talked about methodology, define what we mean by sentiment, and I'll get into that a little bit later in terms of how we arrived at our definitions, how we structured our data. Generate a process based on that definition to prepare it for analysis, and then test a number of open source methods for conducting sentiment analysis. So the data preparation part, what we did was take 6 weeks of chat transcripts. We divided them up into what we called utterances, which is basically one line, one message that was sent. So it could be anything from a word to a full sentence to multiple sentences. And tried to remove some noise, so we did some analysis to determine, we looked at overall length of chats to find some that were sort of not actually chats, but just someone saying, hey, are you there? Strip a lot of that out. In looking at the data, there is a lot of noise in it, so thinking about removing canned messages, things that we automate and send from the librarian end, as well as looking at things like single word utterances. So what we did, we used Vader, which is a lexicon, and scores words for sentiment, positive and negative sentiment. If someone had a single word that was something like great, we wanted to capture that because that was indicating positive sentiment. But if it was just something like and, that was going to kind of waste our time to analyze, so we stripped some of that out. What we did, and this is similar to other studies that we researched in preparing this, was create a gold standard human evaluation set first. So we had myself and 2 other coders. We developed a code book and pulled the initial data and marked it as positive, negative, or neutral, and then developed from there And then that became the basis. We then took the majority of the 3. It was a total of 5,000 chats that we ended up, or utterances that we ended up pulling from chats to code. The next part after that was preparing. So we had our data ready. We had it coded as sort of the standard that we were going to evaluate all the tools against. So we started researching similar domains where you have short text type messages. So Twitter is a big one there. Movie reviews was another one that a lot of the literature is about. And one of the interesting things for a lot of those, and one of the reasons they're studied, is that both of the examples I have up here on the slide are considered to be sentiment heavy. A lot of the content that you find is not neutral statements. It's a lot of subjective statements. That turned out to matter quite a bit when we started looking into our own analysis and results. One of the things that we found, and I don't think I have it up here on the slide, but I looked again at some of our data results. What we found was from our 5,000 randomly selected utterances, only about a quarter of those, it was about 24%, were rated as subjective by the human evaluators. So that's a very large amount of neutral responses that we saw both on the librarian and the patron end. The other thing we found as we went through these was even when we did have subjective responses, it was about 5 to 1 positive. So, of course, librarians are friendly people. As a reference librarian, I'm glad to see that we're being positive with people. But again, it's sort of made for an interesting data set that was quite different from what you would see in the literature on a lot of sentiment analysis in social media. What we used to evaluate against, I mentioned Vader, so we used that, which is basically a lexicon where they rank words and have an algorithm that calculates the sentiment score from that. And then some automatic classifiers. We used scikit-learn to apply these. And what we ended up finding was pretty good results. So typically in the literature, what I saw for a lot of the social media analysis of sentiment, if people were doing really good, it was upper 80s, low 90s in terms of precision or F-score as they were scoring those. I mentioned the uniqueness of our set in terms of a low amount of sentiment-bearing utterances, so I tend to think that probably had some influence as well on getting the slightly higher scores. There were just more neutral things in there. And one of the things that came out of this as well was that it might be more useful to, in the future, to just using the gold standard data, to just look at subjectivity versus objectivity. The whole point in doing this is to find chats where some sentiment is expressed, some non-neutral sentiment is expressed, with the idea that that would then reveal a useful insight about user feedback about using library services, library website, library collections. So it doesn't necessarily need to be a positive or a negative one to be useful from there. There's super tiny type up here for, this is a number of the words that had high or low sentiment value. The interesting ones, so on the red side there, the negative sentiment, that is, a lot of the ones were people apologizing, so saying sorry. There were words like frustrating that one might expect to hear from users, but a lot of it was users apologizing because they couldn't figure out how to use library systems. A lot of the positive end as well were people saying thank you, and so that was usually then reflective of you would need to go back and look through the couple utterances before to figure out what they were thanking someone about, usually about some guidance for using the website, just overall having a librarian there to help them, situations like that. So that's the quick overview of what we did with this. Our next steps are really looking into how to make this a little bit more mainstream. There's a number of ways to take, since we did end up with a fairly limited, compared to other studies, vocabulary of sentiment words. There's ways to use that using expectation maximization and other methods to then run this data. We had 5,000 that we started with. We could run it against a couple 100,000 utterances, try to expand the lexicon automatically, and then again start applying this into production to learn more over a larger set of data than the 6 weeks that we started with. And really for both of us, it was interesting to see the algorithm talk and fake news before. We're trying to recognize that as robots slowly take over and tell us what to think, we should find ways to be part of that process. Thanks.
Thanks, Robot Overlord. So we have 5 minutes for questions, or less than that now that I've spoken. Do we have some questions for these great speakers? While I try to get this to stop clapping at itself. Any questions? Oh, in the back.
I just had one, just a weird thing I noticed on your chart. Left parenthesis was listed as a negative sentiment word. I'm just curious what caused that. Was it a lot of colon, left parentheses, frowny faces? Or?
Good catch. Yeah, emoticons are actually, so one of the problems with social media analysis for sentiment is sarcasm and trying to interpret. So there's a lot of things you have to put into your algorithm to try to figure out what the actual sentiment is, if it's been negated, things like that. But emoticons are usually considered to be really strong indicators because they are not used sarcastically as frequently. So I think that was the case. That was on the negative side, so that's basically frowny face. And then one of the ones on the positive side was an exclamation point, which was usually a strong indicator of positive sentiment. So good catch.
Was there another question in the back? Wait for the mic. I know it's just bursting out of you. We're super excited.
Hi. I don't know, would you ever get like a good number of like troll chats? So for example, like just somebody who says something ridiculous, or, I mean, was that something you accounted for when you were coding? Would that be considered neutral? Because I imagine that those would have a lot of like negative sentiment kind of values.
Yeah, they could. Those could actually be overly positive or overly negative. We weren't looking at chats as a whole because we randomly pulled single lines from each one. So we didn't, that was not one of the things we accounted for. We did account for other things. For example, if someone just pasted a citation in, we would score that as neutral. And then we were curious about how, like the lexicon, which might not realize that, might score it versus a classifier, which would look at the human ranking and factor that in. But yeah, troll chats were not something that they're not something we get a lot of, but they're also not something that we necessarily had as part of the scoring.
All right. Thank you again to our speakers for this great talk. All right, next we have Deep Learning for Libraries by Lauren DeMonte and Nilesh Patil. I'm sorry if I didn't get that right. And yours was the PDF. Okay, and let's, where are you at? This is what I want. Yes, all right.
It's not on, oh, yes, all right. Hi everyone, I'm Lauren and this is Nilesh. And today we're going to discuss a pilot project that uses deep learning to support library space assessment. And our goal here today is to really showcase a practical use case for deep learning in libraries and to show how data science methods can be used to solve real-world problems in our spaces. So I'm going to provide an introduction and context for the project. Nilesh will discuss the development of our deep learning model, and then we'll have a quick outline of our next steps at the end of that. So before we begin, I wanted to let you know that we do have a GitHub repo where we can let you guys look at the code and some sample files that we made available as we describe the project. I'll make sure I tweet it out when my part's done, so it's an easy to access link. So let's jump right in. This is Rush Reese Library, which is the main library at the University of Rochester. And Rush Reese is an old and complex building. The original structure was built in 1930, and an addition was added in 1970. So the addition is actually the squared-off building that you see in front of the tower. And then since the 70s, there have been many internal renovations, creating a kind of Byzantine structure throughout. And so the most recent renovation is Lamb Square, which you see on the right. Yeah, right. And as a result, there's more than like 5 entry points into this building across multiple floors. So there's 2 official entrances at the front and the back of the building, and then there's entry points from other campus buildings and through tunnels and bridges. So there's a lot of people who pass through this space. And complicating things further, the library is a main stop on our university shuttle system. So people who don't even want to go to the library often pass through the building just to get to where they want to go to next. So we don't know how many people come to the library, which is a really challenging thing when we're thinking about services, we're thinking about staffing and hours and all these kinds of really core questions. And we're still, we don't know how many people come through the building and how many of those stay to actually use our spaces and services. So we can't make evidence-based decisions, and we can't provide data to decision makers about our impact, our reach, and sort of how to grow what it is that we're doing. We're kind of operating in the dark. So we launched a pilot project to see if and how we might close this space assessment gap. And the goals of the project are really to identify automated and scalable methods for conducting space assessment, to experiment with those methods, and to develop tools to support planning and decision-making for operations and for service design and delivery. So for the pilot, we decided to focus our efforts on one bounded space within Rush Reese Library, rather than tackling the whole building at once. And ended up picking Lamb Square as the pilot site. So this is actually the floor plan of level 1 of the building. And this is where Lamb Square is located. So you can see it's just off the main entrance, and you actually need to pass through it to get to the stacks, which are located right under the word Lamb. So it's a well-trafficked and clearly defined space with 4 entry points. Number 2 actually connects to another campus building. So this site provided us the kind of complexity that we could use to experiment and to see if we could actually scale some of these tools up to maybe assess the entire building. And the other benefit of this site is that each of these entry points happens to be monitored by a set of smart access control gates. So these gates employ bidirectional sensors, which to track the number of people who pass through them, but it also lets us determine which direction people are passing through. So we actually have a sense of whether they're entering or leaving the space. So this sensor data seemed like a good starting point for our space assessment pilot. We decided to work with this data to see if we could get at the number of patrons visiting Lamb Square, and to see if we could use those data to actually predict how many people might come through the next day and the day after and the day after that. So we organized our project into 4 milestones. We thought we were like really getting our stuff together here. We'll collect and analyze the sensor data, develop the deep learning algorithm to predict future traffic patterns, we'll train the algorithm, and then we'll create a data dashboard so that our decision makers have a point of entry to look at the data. They don't have to know any of the ins and outs of deep learning. So it seemed like a fairly good plan, but we ran into some serious issues at step number 1, accessing the data. So our gate vendor has an online data portal that's supposed to capture all the sensor data. And we assumed at this amount we could get at every sensor ping. But we assumed incorrectly. When you log into the portal, what you see is something that looks like this. It's aggregate data based on the time period you select, weekly, hourly, daily, that kind of a thing. Not what we're looking for, not what we could use to sort of undergird our model. But in the portal, you could download an Excel file, and we thought, surely, this would give us the sensor pings. Nope, it's the same aggregated data. But you could download an XML file, so we thought, okay, this is gonna be it, but I bet you can guess what's gonna happen. The exact same aggregate data. Which brings us to our first lesson learned. Check to make sure you can get the data you need. Don't make any assumptions about what the vendor will provide you, about what the system will provide you, and do all of that before you set up your milestones and your timelines and get approval and do all of that. So don't do what we did. Definitely validate your data first. So our next step was actually to contact the vendor and to find out how can we actually get at this sensor level data. And you might not be surprised to learn that we got pushback. We were told the data were proprietary. For a variety of reasons, we did not accept this answer. We spent most of our project time working with the vendor to make the case that this was data from our patrons, from our spaces, being sent to a box that we set up and that we own, and that the sensor pings were distinct from any kind of proprietary communication protocol. So having the technical knowledge to make that case was really important, as was having the fortitude to keep at it. So eventually the vendor relented, sort of, by providing us access to a log file with minute-by-minute sensor pings. So this was another lesson learned for us. So through these kinds of technical projects, we actually have the opportunity to become strong advocates for our patrons and for our data. We have the power to demand more and to demand better. So take those opportunities when they come at you. Be that person, be that advocate. So what we ended up with was a data set that looks like this. It's date and time stamped sensor pings from each of our gates. And this is the data set that actually formed the foundation of our deep learning model.
So what Lauren has discussed in the figure, as you can see, is just the first 2 steps of the milestones that we had actually planned for, planning where to get the data from, how it would look like, and then finding some basic patterns. What I'll be discussing is the next 3 steps, actual data munging on the model file to get into a format that the model can be trained on, which is a recurrent neural network model, and then implementing this model as a solution that somebody who doesn't have a programming background or only wants to look at numbers, not the low-level code that I come up with, can actually look at the values. Another way to look at this whole project beyond the milestones that we discussed is how the data flows. We divided that into 3 stages. First one is at the gate level. You have sensors, you have raw data, every second level ping that is being aggregated at a server to a minute level, and we get that. Second stage is import that. For us, second stage was importing that data into Python and doing every data munging task, model development, visualizing, initial visualizing within Python. And then finally, output whatever predictions we get from the model along with the original aggregate data so that visualization in Tableau can be developed. And that's what we decided on, how to proceed forward. Now, the actual data processing, pre-processing part. We use Seaborn and Matplotlib for visualizations. You might have heard of that. Then SciPy was just to determine outliers, what value should we replace it with, percentiles, mean value. The problem that we encountered with standard replacing, say a missing value is there, is the standard approach is replace it with something like a mean value or a median value. But when you have lots of missing values, you'll get a huge peak to the distribution of your data, which will bias your model in the wrong direction, and you don't want that. We use pandas and NumPy to actually replace those values, to shape the data into a format that the model can be trained on, rescale it so that gradient updates can be easily made to the model, and then we stored all this data as NumPy arrays. Nothing complicated in that, just simple functions within Python. If you just Google search, you'll find how to do that. Finally, the machine learning model itself was developed using Keras and TensorFlow. TensorFlow is a deep learning library by Google, which was made open source a couple of years ago, and Keras is a high-level API for that, and that is it. The model itself. We decided to go with recurrent neural networks instead of traditional time series modeling. The reason being, in time series modeling that doesn't use recurrence, what we do is for historical context, we add additional variables. What was the value yesterday? What was the value before yesterday? What was weekly average for the last week? Monthly averages. Some seasonality is added using an additional variable, using a dummy variable. And we didn't want to do that. That would have been a very complex task for us. So we use recurrent neural networks. The learning is done using a technique called stochastic gradient descent. You can look it up, or you can talk to me after this. The simple diagram shows what the overall view of the model would be. There's an input value coming in, the model is learning something, and there is an output value corresponding to that. Where the recurrence, the persistence of this model happens is that whatever the model is learning at t equals to 0, some part of it is being passed for the next stage. Whatever it learns at t equals to 1 from the difference or the loss that it had for the previous step is passed on to t equals to 2. And we move on from that. That is just for a single gate. The next step is to train this model for 4 gates and 8 sensors so that we have incoming as well as outgoing values. If we did a manual model or a simulation, we would have to hand code everything, maybe make some assumptions for which we didn't have any data available. The model learns all these interdependencies which are distributed across time. Maybe a lot of people come in at 2 o'clock during lunch from gate 1, and they leave at 8 o'clock in the evening from gate 4, where the buses in the university actually stop. And that's what the model is trying to learn. Finally, what we do is we append these predictions to the original file and write it out as a plain text CSV file. The goal was to provide a high-level, clean interface for everybody. This was our expectation. Simple visualizations, which anybody can understand. This is the net flow for the library throughout the data that we have available. This is where we encountered a sensor malfunction. As you can see, the sensor values dropped by multiple thousands. The sensor, for some reason, was malfunctioning. There were 30,000 pings within a single day. And this continued for a week, which is how we realized that something is going wrong here. Another dashboard for just determining how many people are coming in for a weekday for a particular hour. So we found out what the busiest hours of the week were. Simplified visitor counts. Yesterday, how many people came in. Last week, for a semester, for a given year, throughout our history. And then, this is the final dashboard that we have. Predictions being appended to the original file, and whatever uncertainty measurements we could get from our prediction, that appended to it.
So our next steps, so this was the end of the pilot, basically, and we think that we had success. We were able to actually identify the anomalies in the sensor, in the data, which our vendor doesn't actually provide, so that was a big win for us to be able to sort of show when the gates are working and when they're not. And we've actually decided to add 6 more gates to our library system, so we're going to have at least 2 more gates within Rush-Reese, and we're going to gate up our science and engineering libraries as well, with the idea that we're going to create this overall view of all of our library spaces. We're also working with our director of assessment to develop a sustainment plan for this. So we are lucky enough to hand this off and not have to keep at it. So it's somebody else's problem. Thank you. We're very happy about that. And we're also hoping to dig a little bit deeper into how do we use this data to actually model traffic flows across the building, but also across our various buildings. And that turned out to be a much more complex problem, and even sort of conventional sort of traffic, like transportation engineering models don't actually account for how people move. So that's something that we're really interested in exploring further. Thank you for your attention.
So I think we have 2 minutes for questions. Is that correct? About that? Yeah. So does someone have a question that they would like to ask of these excellent speakers? We have someone over there.
I have a quick question. So I think it's really fascinating that you guys gathered all this data and have actually prediction. So do you have a plan to actually feed the data back as you gather them to compare, to retrain the neural net to see how it's going to go? And also I'm curious of what kind of, you shared something like you're planning to add more gates and stuff, but did you consider that as a sort of the project outcome in the beginning, or was that something that you kind of like got to realize that this might be the case of application? So those are the 2 questions. Thank you.
I'll answer the first part. That was one of the reasons we went with LSTMs, recurrent neural networks, so that we can just update the model without modifying a lot at the back end. We'll just update depending on the values come in. If we use traditional modeling, we'll have to start from scratch, remodel everything, remodel the data, and find out if now there are any outliers or anything like that.
And the multiple gates, I think, was always a dream from our dean, because even our science and engineering libraries have multiple entrances. We just have these wild spaces. And so being able to actually get fairly accurate numbers and counts and understanding of how our patrons move through our spaces was always the ultimate goal. So that was something that was a kind of hazy target in the distance.
All right. Thank you very much again to our speakers. Yay. All right, our next 15-minute talk is going to be Deep Learning and Historical Collections by John Hessler. And there it is. Please.
Yes. Good.
All right, cool.
Okay. Well, thank you very much. Another talk about neural networks. I'm going to be talking about a pilot project also. It's a little bit different. What we're attempting to do is really teach a computer to read maps. And by reading maps, that means understand what's on them, understand how they change historically. We're using as a data set the USGS TopoQuad series, training a convolutional neural network to recognize features, and then also training the convolutional neural network to recognize changes as it goes along. We are running this using Tesla 100K GPUs on the Google Compute Engine through TensorFlow. So that is really the system that we're using. Now, convolutional neural nets have been extremely successful lately. A lot of you might have heard about AlphaGo. AlphaGo is the Google Mind program that has just beat the world champion in Go. We don't really know how convolutional neural networks work at their deepest level. We understand empirically that they give great results, but we don't really understand the actual mechanisms by which a convolutional neural net is actually learning to identify images. And really what we're looking for when we do this in a convolutional neural net is to teach the neural network to recognize high-level and low-level features in either images or whatever. In this case, it is an image because we are inserting a series of historical maps. One of the things that AlphaGo showed was that convolutional neural nets are also extremely creative. After the defeat of the world champion Lee Sedol, he came out and basically said, what does creativity mean? If this system can beat me, and beat me at a game that artificial intelligence thought was at least 10 years away, how are these neural nets working and how are they learning? When we talk about a neural net, and I'm not going to go into a lot of details here, but basically we've got an input image. We have a lot of nonlinear layers where we are basically training weights, and we are inputting a huge series of parameters. There's a sort of decoding and coding as the neural net learns. The big issue with neural nets in any convolutional neural net system is training data. That's always the difficult part. Now, when we look at how neural nets work, and I couldn't really give this talk with at least saying something about this, and I just want to show a little video here, if it works, of how a neural net learns. Now, basically what we're looking at here, and I'm going to pull this back and stop it. This is the beginning of a neural net. This is not actually coming up on the screen.
So let's see if this needs to be, nope. Okay.
Yes, there we go. Okay. So basically what we have here is a view of a neural net. The first layer is all the way up in the top right-hand corner. That particular layer obviously knows everything about what you're about to input, and that top corner is both the most information about the output and most information about the input. If we begin, if I press the start button here, what we see is the network is beginning to learn. And we see all of the layers moving to the right. And so basically, each of those layers is beginning to learn something about the input. As we keep going, we begin to stop and we begin to move in the other direction. And what we will see here is it is moving backwards. So what the net is actually doing here is it's beginning to forget information about the input and learn all the information. In other words, it's discarding information in order to get to the output. In other words, it's discarding all of the high-level or low-level information that it believes is irrelevant to making an identification or classification of the output. And that's really what a neural net does. We don't know exactly why it does this and how it does this. There's a lot of research projects currently underway which are looking at that. And I'll get back to the slideshow here. And I'm just going to show you this one slide here. So this slide basically shows that phase transition. These are the network learning. You'll see that the standard deviation and the mean change. So in other words, we have basically, in the beginning, we have high means and low standard deviation. And then when the network begins to forget information and to learn what it needs as the output, there's this phase transition in the information flow within the network. There are many theories of deep learning. I'm not going to go into any of these mathematical theories that are trying to be explored at this point. And I'm not going to talk about those. Anyone who wants to talk about them can talk with me after the whole session's over. Now, the project we're actually working on uses an inception network. Basically, this is a Google TensorFlow network. And the only reason we need to use these inception layers, and I'm not going to go into that, but this is a specialized little loop that takes place in a normal convolutional neural network, is because basically the computational space that we're working on when we're talking about map images is gigantic. And so if we want to do this filtering, so the way a neural network, a convolutional neural network works in this case, is each of those layers basically acts as a filter. And it's looking for features in the image. And in this case, it's looking for features in the map that we've trained the network to identify. Now, when we're talking about a convolutional neural network and a thing like we are working on here, we have a huge number of parameters. This is a super high dimensional space. If we didn't use an inception layer within our convolutional neural network, you can see we'd be at 120,422,400 operations for this. This is computationally not intractable, but difficult. Using an inception layer takes us down to about 12 million, which with the GPUs is really not that bad at all. So basically 12 million operations per layer. This is a very high dimensional parameter space that we're operating in. We use a couple of pooling layers within it just because in standard neural networks, pooling layers have always been in there. We don't know why, but for no other reason than they really do improve the performance. The convolution, the one-by-one filter that we're using on the convolutional network reduces the dimensionality of the space. We're using as our nonlinear, for all those who know how to program neural networks, we're using a ReLU as opposed to any of the various other nonlinearities that one would put in. Now, as far as the network, where the results go, we have been working with, as I said, the USGS topo quads. And really what we've been looking to do is basically place these things into the neural network, these scanned images, run the trained neural network, and have the neural network identify various features. Now, deep learning is certainly going to change the way all of us in this room do business in the very, very near future. When we're talking about large archives and things that we can look for in digital images, auto generation of metadata, in the case of what we are trying to do here, the Library of Congress, for example, has 6 million historical maps. Digitizing them is easy, but writing up metadata and figuring out what's on them is something that is totally different. If we can train a deep neural network in order to be able to extract automatically the metadata from those maps, so in other words, in the case of the USGS quads, we began looking at railroads. We took railroads because it was a very linear feature. Not every map had it. And so what we did is we took a whole series of historical maps. We've used about 15,000, and we've used about 900 for the training. The training of this is the most difficult part of this project. Coming up with training data and annotated maps in order to feed into the convolutional neural network. Basically, we have a team of slave interns who are basically annotating these things in a way that's proper for us to understand the training of them. We started out with very bad results early on. We were only able to basically identify about 37% of the railroads. We now have added much more training data, and we're up to about 73% accuracy on the features. Our learning curve here is fairly low at this point. We expect to probably be about 95% of those features probably within the next year or so, and then we'll move on to a more comprehensive attempt to identify most of the features. One of the things we're also attempting to do is, after we get that data, is in fact to then quantify it. So in other words, one would see land use changes, changes in coastlines, things like that, and attempt to quantify that, but that's very far down the line. But as I said, we are in a revolutionary period right now. Deep learning is going to enter into every aspect of our work, especially in large historical collections. Those of you may know the Smithsonian just recently had an extremely successful program of identifying more than 2 million digitized herbarium specimens, which was a very successful application of deep neural networks. Lastly, I want to say that at the midwinter ALA meeting, which just took place last week, the board has voted to start a deep and machine learning interest group, research group. It's going to be chaired by myself and co-chaired by David Lacey at Temple, who's probably here somewhere. So that'll be open for membership in the next couple of months. We're planning on having a fairly extensive outreach as the ALA progresses and as we look for more applications in this area. So thank you very much.
Thank you very much. We've got 3 minutes left, so are there questions for this speaker? I see a couple hands in the back, I think.
Hi. It's really interesting that you're doing this to do extraction of features from maps. I'm curious, did you treat each map itself, each quad sheet, as its own independent entity in which you're extracting images from, or did you consider the fact that, as you identified through time, it's the same location? If there's a railroad here in the past, there might be a railroad here in the future, and you could do things like understand the real world itself actually has consistency.
That is the hope. At this point, we're just trying to get it to identify features. But we know if we get it to identify features, we will be able to actually say that in this particular map, there aren't those features. The reasons we picked the USGS quads was because we have a long historical train of the same area and the same map. We get rid of all the extraneous data on the outside, all the latitude and longitudes. We're just treating it as an image at this point. Obviously, later down the road, we would want to think about the sort of geo-rectification implications of that change. There are a couple other groups. There's a group from the University of Miami working on just that problem and looking at deforestation and land use on maps, doing also deep, using convolutional neural nets, who is doing a lot of the geo-rectification stuff, but we're not doing that yet.
Another question in the front. Sorry, right over here.
For your actual model,
You said that you are using Inception.
Mm-hmm.
Have you tried like ResNet or DenseNet, which might give you better features or at least make the computation easier?
We haven't yet. That is our next step. We're also looking at kernel methods, which we think might, because the kernel methods are much more comparison, some of the Hilbert space kernel methods might actually be even better than the convolutional nets. We went this way because it was easy. It was the first easy step, but that is our next hope. So
there's a startup called Descartes Labs, which is doing geovisual search.
Mm-hmm.
They also employ neural networks to identify features and then make that space searchable.
Okay.
Maybe that will
I'll
be
have to take a
useful for
look
you,
at.
right?
One more, 30 seconds.
All right. Thank you very much. And so our next speaker is going to be Jeff Mixter for 10 minutes. Jeff Mixter is going to be giving us a talk called Using a Large Metadata Aggregation to Improve Data Reconciliation. So thank you, Jeff.
Great, thanks again. My name is Jeff Mixter. I will not be talking about neural networks or anything super fancy like that. Rather, I'll be talking about taking strings and matching them to identifiers in controlled vocabularies. So our motivation for this project was we wanted to quickly reconcile bibliographic headings with identifiers from controlled vocabularies. Or put another way, we wanted to more efficiently find the needle in the haystack when you had tons of haystacks to potentially search through. So our first step was to just do an environmental survey to see how others have tackled this problem. And two approaches that really influenced our thinking were Google's PageRank, which we kind of boiled down to pages that are linked to more often are more relevant than other pages. As well as Wikidata's autosuggest implementation, which, similar to PageRank, boils down to entities that have more related Wikipedia links are more relevant than other entities when you're doing sort of autosuggest searching. So what was unique about both those projects was they both had sort of data sets that they used to determine relevancy. So this got us thinking about whether we could use enhanced WorldCat to determine the relative importance of entities, bibliographic entities, similar to Google's PageRank or Wikidata's autosuggest. And I should mention that we used, in this experiment, we used enhanced WorldCat, which is sort of a version of WorldCat maintained by OCLC Research that, as the name implies, has been enhanced with additional controlled vocabulary identifiers. So we were working with a very, very identifier-rich data set. So the method we used was called a one-ring neighborhood sort of graph method, which in practice meant we analyzed every single record in WorldCat and out of it grabbed all the identifiers we could find and then summed them up, found the frequency for them. So for this simple example, what we would have is 3 unique identifiers, the first of which had a frequency of 2 and the others of which had a frequency of 1. So to test this idea, we use a small number of controlled vocabularies, specifically FAST, VOF, Library of Congress's Thesaurusographic Material, and the Getty's Art and Architecture Thesaurus. And then we basically did that frequency analysis. One of the tenets for our work was we didn't want to build anything we didn't have to, primarily because we didn't have time, and I'm also somewhat lazy. So we wanted to use off-the-shelf technology wherever possible. So the workhorse for this project was really Elasticsearch. It's a well-known popular text search engine. It provides sort of the standard TF-IDF ranking, but it also has functions to modify ranking. Specifically, it has a boost by popularity function as well as a sort of more complex function scores query method. So in our first attempt, for the identifiers in that list of 4 vocabularies, we got the frequency counts for them. The second step was a little more complex. We merged duplicate entities across the vocabularies and summed up their frequencies. So a good example of this would be Abraham Lincoln's VF identifier its frequency was added together with the FAST authority record identifier for Abraham Lincoln's frequency. So this would prevent us from having 2 Abraham Lincolns floating around the index, and more problematic, 2 Abraham Lincolns had different frequencies associated with them. And then basically we took these frequencies and applied them to a boost by popularity value, which basically means the out-of-the-box Elasticsearch score was multiplied by whatever this frequency is. And in short, it didn't work. In fact, it didn't work at all. It was really, really bad. And the reason for this was that the frequencies were not normally distributed. So many times, Elasticsearch scores were being multiplied by 1, but sometimes they'd be multiplied by some number like 7 million. And so the result in their sort order was either nothing really changed, or we completely broke the TF-IDF algorithm. So we played around with the numbers a little bit. We applied some pseudo math to try to normalize the frequencies, and the results were much, much better. But in fear that someone would ask us to explain how we did this, we decided to try this experiment again. And we decided to actually do our due diligence this time and consult our math wizard, William Harvey, who after hours of reteaching me math and continuously explaining what those silly Greek symbols meant in equations, finally settled on proposing that we use a linear combination, which is very similar to the way that learn-to-rank algorithms work. So basically we have features that you sum up, and then that is the final score that we can use for the rank order. So in this attempt, we used Elasticsearch's function score query method, which allows for this sort of linear combination type of re-ranking. And in our simple use case here, we only had 2 features. The first feature was Elasticsearch's TF-IDF. We didn't modify that because we didn't know how to, and it seemed unnecessary. And the second feature was the log of the frequency. And we used the log of the frequency to sort of help normalize or tamp down the really, really high numbers, and also to boost the very low frequency numbers, or at least make it slightly more normally distributed. So the results were actually really good, and it was actually then now something that we could actually sort of mathematically defend, I guess, though I should not be the person trying to make that defense. So in the end, what we were left with was something that worked well for the use case that we were trying to solve, but it also came up, we also presented some problems or quandaries that we're looking to explore in future projects. And the first of which is sort of, I think, more of a functional problem, was that this relevancy ranking actually might not fit a lot of use cases. So if you have a very sort of specialized collection that has people or places, et cetera, that are not well represented in either controlled vocabularies or conversely in WorldCat, this solution would really not fit your use case. It wouldn't solve your problem because you'd still have to do a lot of searching for the thing that you wanted to find. The remaining problems are sort of more technical issues. There's this need to refresh the index. So as the number of identifiers in WorldCat increases, decreases, migrates, whatever, we need to recalculate these frequencies. There's also a lot of complexity in merging and correlating the vocabularies, so to make sure that you don't have duplicates in your vocabulary, or in your index, is somewhat complex. And there's also then finally accounting for new vocabularies. So we used just 4 vocabularies in this pilot, or this experiment. There's obviously a lot more vocabularies we'd like to roll in, and as we do that, the complexity for refreshing the index and then also correlating duplicates increases. So these are things that we're thinking about right now and hoping to tackle in future research pilots. So thank you very much.
Great, thanks, Jeff. I think we have about a minute or so, a little bit over it for questions. If someone has a question for Jeff. Any snarky comments to make not on Slack about pseudomath? Nope, question?
Just the word frequency and the fact that your frequencies weren't numbers from between 0 and 1. Could you just elaborate a little bit why?
Yeah, so this is the history major answering this question now. So I'm sorry, when I said frequency, it meant just the sum of the number of times the identifier was used across the collection. We could have normalized it to something between 0 and 1, but we didn't. So.
All right. Thank you very much. Thank you again, Jeff. All right, and for our final speaker in this block, we have Big Data in Libraries, Creating an Analytics Hub to Reveal Patterns, Trends, and Associations in Your Library by Joel Shields. And let me find that. That was the Google Drive one, yes. Is that? Cool.
Okay, everybody. So far we've talked about some computational AI, some incredible algorithms. Now we're going to talk about spreadsheets. So big data, what is it besides a nice key term that got me selected to speak today? It's going to be looking at some patterns and trends in data that you're collecting in very large amounts that are going to be related to human behavior. So within libraries, some good examples of this are Google Analytics and website use, some door counts, your circulation records, resource use, and just about anything else you can think of. And as we all know, all this data is always siloed. It doesn't talk to each other. The vendors sitting out in the hallway out there, I think we can probably blame some of them for this. They don't give us access to the data. So our director at the Washington Research Library Consortium came to me about 2 years ago and asked me to put together, or I should say he said, hey, wouldn't it be great if, to put together a dashboard that is visual for our library directors to look at, staff at our libraries to be able to interact with, and I wanted to have information about our catalog usage, I wanted to have information about a lot of the reports that we run on the back end of our catalog. We have a large shared collections facility. I want to be able to show the numbers from that. And by the way, I want it ready in about a month. And then he closes the door and walks out. So I get started on this project. A bunch of other people here have talked about using Elasticsearch, Logstash, and Kibana, which is referred to as an ELK stack. And so we got a very rough rudimentary version of this up and running, and then the lead developer on it took a job to leave and go somewhere else, work on Folio. Thanks, Kurt. Appreciate it. You're in the audience. But in actuality, all joking aside, with Kurt leaving, it actually led to this project becoming what it was. So Kurt, actually, thank you for this. So I broke it down into 3 steps. The first step was identifying the types of metrics and data that I need to be able to collect. Number 2 was the big question mark, how am I going to get all this data to talk to one another? And then third was an even bigger question mark of getting all this online so that people can see it and make it useful. And in addition, I wanted to make it even more difficult for myself. I wanted it to be cloud-based so I could access it from anywhere. So enter what I refer to as the FAT stack. And FAT stack is a group of web-based tools to beautifully display your data online. So what FAT stack does is it takes something that looks like this and turns it into something like this. So the capitalized part of FAT stack, the F stands for Font Awesome. This is a freely available resource online that uses CSS to generate images for you. Not that long ago, you'd have to pay several $100s for an icon pack to be able to legally use it. This is completely free, very easy to use. The A is analytics, Google Analytics. Just about all of us use it. We don't really take full advantage of it. It's pretty restrictive as far as who you can share the information with. T are what I refer to as the antique reports. It's creative tables and lists And these are all the old reports that you've been running into your library for who knows how long, and they haven't changed in probably 15 years, but the information is useful to somebody. And then the S are the good old spreadsheets, which you may be rolling your eyes right now, but by the end of this, hopefully you'll have new appreciation for it. And what Google Sheets does is it allows you to plug in all these different resources into it, and it'll translate it into a language so that they'll all talk to each other. And with it being based in the cloud, we can access it from anywhere within a web browser. So that gets me one step closer to getting the information within a web page. So let's quickly take a look at Google Analytics. As it happened with this project, when I first got started, within that week, Google released an official Google Analytics add-on for Google Sheets. And you just install it, you click on the button, it'll look at anything that's linked to your account. You can select the different parameters that you want to find and hit generate, and it'll put it out all into a spreadsheet this way. And then once you're ready, if we go back, you can see there's an option here that says schedule reports. And when you run that, it'll automatically generate all your data. And here's an example of what it'll look like. It's been put out into a Google spreadsheet. So with it being in a spreadsheet, you can use some of the tools that are available to you, like putting in today's date, doing sums, doing averages. So if you put in dynamic fields, then every time you run this report, it's going to give you new data. It's not just going to be static sitting there. And since you can schedule these reports, you just set it up once, hit go, and then you just sit back and all your data is automatically generated for you. So once you've set that up, and obviously you're going to have more than one website, you're going to be able to have all these multiple spreadsheets. With Google Sheets, you can get them to talk to one another by referencing what is called the key. So if you look at the URL of any Google Doc or Google spreadsheet, there's a long string. You can see it here in blue. And that string is going to show you, if you put it into a formula that you drop into a cell within a workbook, then it's going to allow you to reference that cell within another spreadsheet. So again, this sounds pretty boring. But once you start getting all this information together, you can compile it all into one spreadsheet, and then you can compare that data against other sources. So I have an example here. At WRLC, we have 8 instances of Summon running, and we have Google Analytics running on each one, and Summon does not provide you an overall count for anything. So what I did was I took all the individual Google accounts, put them into spreadsheets, ran the reports, and then did some cherry picking of the numbers that I wanted from each one, put them all together, and then did a sum of it, and that gives me my full Summon page views. I can put into a nice chart. I can compare by university very quickly, and then with these, you can publish them and embed them directly into a website. You can embed them into report documents, things like that. So already I'm starting to break down some of those self-imposed silos that we have. Okay, next we have antique reports. These are reports that are a lot of times generated as static HTML, say every month, sometimes even put out as XML or RSS feeds. So I have an example here of, we have a large shared collections facility. With the numbers here, they've actually gone up since January. It shows we have about 2.6 million volumes stored in this collections facility. And so we generate this report from the system we use to manage it, and we put it out into a static HTML page that's hidden away that hardly anybody ever looks at. And we wanted to be able to bring that to the forefront. So good old Google Sheets. It has a function that lets you import URL, and you can tell it to look for a table or for a list, and it'll drop that information into the cells within the sheet. And then once it's in a shell or within a cell, you're able to pull that out and play around with it, and it'll recognize it as numbers. You can do any sorts of computations with it. But the problem with that is Google, by default, likes to cache when you do these URLs. So I had to come up with a way to trick it, and the way to do that is to append the URL with a hashtag, and then I wrote a little bit of JavaScript in the script editor that will append at the end of the URL the day's date and the time whenever that script runs. So it's going to create a unique URL every single time, but it will not affect your URL when you load it up in a browser. And the result of that is Google will think it's a new URL every time you run it, and it'll go back out and pull in that data for me. And similarly to the Google Sheets, you can schedule these. These are granular to 1 minute if you want to, and then you sit back and enjoy, and the data gets pulled into your spreadsheets. It also supports XPath, so if you want to get really fancy with it, you can even go out to a website and pull in very specific tagged information from that into a spreadsheet. So for example, when someone was doing specific updates to their system, they had their update schedule posted on their website. I was able to go out and grab that using XPath and put that in to a spreadsheet and then display that on a website showing what their schedule is as they update it in real time within another web page. And then also, say if you have some other reports that are generated via spreadsheets or in Excel or as XML, you can just upload those directly in. And for that, I wrote a script that will look at the contents of a Google Drive folder, and it'll export that into a Google Sheet. And it provides all the information related to it, and then based off of that, I can start building and manipulating the information. So a couple of things to keep in mind. I mentioned let Google Sheets do the work for you. Using the current date, making references to other cells so you don't have to constantly repeat the process. Referencing other cells within the workbook, referencing other documents using that key that you got from the URL. And one thing I found really helpful with Google Analytics is because all the data is the same, basically the same format. So you'll have like your monthly, yearly reports, top 5 country locations, things like that. So you can create a template with it, and then you can create a workbook, which I called a key. And for that, I just put in some sort of identifying information, and then the ID number that Google Analytics uses to recognize that account. And then in the template that I created, I just tell it, you can see here I'm telling it to reference in the workbook key, cell B2, which is right down there at the bottom. And you can see it'll automatically populate that information in for me. So if I have another new website that I want to run all this data on, I just create a copy of that spreadsheet that all this information is in, go into the key, update just 1 or 2 little things, hit run, and it'll instantly give me all this information for that new website. Okay, so that was step number 1, and sort of step number 2. So I've got all this information talking to each other, but now I need to get it onto the web. Well, there's a couple ways to do that. Talked about publishing the charts. It's going to look pretty good. You can publish a spreadsheet as HTML, but let's face it, that's really ugly, and I'm kind of a control freak, so I want to be able to have more control over this sort of thing. And I need something that's platform agnostic. So enter JSON. Turns out that in Google Sheets, there's a hidden feature that there's a JSON output for all the content that you store within a spreadsheet. And it uses this URL format here. It's that key that we talked about earlier. You just drop it in to this URL, and then it'll output all the data that's in that spreadsheet as JSON. And since it's on the web, what that means is I can link to that and start manipulating that data with different programming languages. So how many of you are familiar and consider yourself experts with PHP? Okay, how about with JavaScript? Okay, how about with copy and paste? Okay, so that group is who this presentation is for. So this may look a little complicated, but really all you have to do is just copy and paste this in, recognize a few little patterns in it, and you're good to go. So what it does is I'm grabbing that key, I'm putting it into that URL that I showed you. It's going through, processing the JSON contents, and if you look here, it's showing up. The way it works is in a spreadsheet is your very first row, it's going to use whatever you put into that first row as sort of the names of your columns, similar to how a database would work. So let's say I created a database of all the lectures that go on here at Code4Lib, and I wanted to include the lecture's date, lecture's title, and the lecture's time. So I have a spreadsheet that holds all this information for me, and then down here below is going to be the actual HTML that I'm going to write to output it to the web. So it would say the lecture scheduled for, and the date is on, and then the title, and then I'll break down the next line. It says it'll take place at, and then the time, of course. And then below that, you can see the output for it, and that specific information will be stored within that spreadsheet. And then you can filter it out using an if statement. So if a row has content in it, and if another row has, let's use George Washington University as an example for this, then I'll output the content in the column beside that. So let's take a look at the result of this. So here's some screen caps from our library staff intranet. This is the data that we're able to share with everyone. And all these numbers update in real time. It gives us a nice look at our service desk stats, so staff can see how we're responding to requests at the universities. We have our catalog compared beside Summon. We have a look at our social loan services. We have, just at a glance, some of the shared collections facility metrics. And all this is created just using a spreadsheet and a little bit of creativity. And it looks a lot better than a spreadsheet, I think. So moving beyond that, I can take these same numbers and embed them within actual content on the page. They don't have to be specific. This is a screen cap from our corporate website that details some information about us. And you can see highlighted in gray that the numbers from our shared collections facility, those are coming from a spreadsheet that's updated monthly and is dropped right into the text in line on our webpage. So this came about from me just being lazy, not wanting to go in and update this information periodically. So I just set it up so it all runs and is automatically updated. And then here's our own intranet for WRLC staff, which you can see, again, it's replicating those service desk stats, lists some of the current projects that we work on. And I'm not having to re-replicate this data every month as it's updated. It all just automatically does it for us. And this is using Drupal for the platform, and you can just copy and paste the code, drop it right in, and it works. So of course, nothing's perfect, so I need to keep track of all these operations that I have running. And so I created, you guessed it, another spreadsheet that's going to reference the update dates on everything that I have running. And I dropped that in and wrote a little script that if the date does not update within 24 hours, then it sends me an email to say, hey, something's going on here. So then I can go look at this list and it'll alert me and I can easily update. So that's using FatStack. It's all free. And start to finish, I got from my first thoughts of it to the working platform up and running in about 2 weeks. So I thought, why stop there? I'll start looking at some even more things I can do beyond metrics. So at WRLC, we have all these moving parts for communications with all of our member universities. And I've been feeding a lot of that info in through FatStack, and then it is all fed in to our website. So this is taking all the siloed information, I can break it down, have it talk to one another, all within a nice visual interface, and then have it update automatically. Same for our array staff, for keeping track of people. When new staff are added in, I can just go in, update a spreadsheet, and all of our websites will automatically update. For collaboration, we have a lot of our projects that are going on at WRLC. We meet and sit down, just update a spreadsheet, and it updates all of our websites and informs all of our stakeholders. The Scholars Trust and also the Rosemont Shared Print Alliance, We have people all around the country that want to be able to contribute to the websites, but they don't necessarily have HTML skills or programming language, or just don't feel comfortable with it. But they can easily update a website. So I just set up a spreadsheet. They go in, fill in a couple cells, and those websites will automatically update. For our annual meeting, did something similar. We used a Google form for registration, and then I used FatStack to process that information, and automatically creates all the name tags, creates emails to send out to everyone, creates the entire website for us, and also for the submissions for presentations. And all that data is all coming from one source. I don't have to touch anything, and the website automatically updates and contacts all the attendees. So the lessons learned from this, number one, I love this quote, is to achieve great things, two things are needed, a plan and then not quite enough time. So that's proven true time and again. So I have about 10 seconds here, so I'll just say that don't come into it with a plan of your technological limits, but instead define your needs and then finish it up that way, and you'll find the means for it. So I'll skip that part. But if you want to take a look at this, I have tinyurl/fatstack. If you go to that, there's a link to this presentation. There's links to live code examples that you can copy and paste, like I said before. And you'll be able to play around with it. And hopefully you'll be able to do some great things with it as well. Thank you.
All right. We have a couple minutes before we need to get into announcements. So if there's a quick question for the speaker, thank you. We can take that. Oh, over there.
How did you deal with size limits in Google Sheets? Are you just doing multiple? I mean, if you're doing historical Google Analytics, you'll run us out of space.
Yeah, currently we're running at current. So I know that Google Analytics goes back, I want to say 5 years, and then they dump their data. So archiving that information is definitely something that we're looking at. Currently we're just downloading that information, exporting it as an XSL file, and then I'm actually able to put that in, and then using that key from the URLs, I can create sort of a quasi-database of all the historical information that way, and we can go in and select it and pull it out that way.
Thank you. All right, another round of applause for our speaker. Thank you very much. Thank you. All right. So I'm going to welcome to the stage our duty officers to make a statement.
Hello again, everyone. We have been made aware that a presentation this afternoon had some problematic language referring to interns as slave labor. The duty officers are aware, and we are following up using the reporting procedures and reporting process laid out in the Code of Conduct. So thank you, and we will keep you updated.
All right, thanks to our duty officers as well as all of our volunteers here. So at this point, I'm going to welcome another volunteer, Jamie, to tell us about the reception this evening, including how to get there and how much fun we're going to have.
This is awesome. So thanks so much. Today was fantastic. I have so many notes. Tomorrow I'm sure will be even better with Mega as our keynote. I want to officially welcome you to the reception at the Library of Congress this evening. We're really excited to have you. I've been getting texts from LC people all day can I come? We can't wait to see everybody. So we're really excited. A couple of things, because I've seen that there's some questions on Slack about how to get there and what you can bring and what you can't bring. So I'll try to answer all of those now, and then if anybody has a question, I'm happy to take it. So first, the Library of Congress is a campus. It's multiple buildings. We're going to be in the fanciest one, the Thomas Jefferson building, and its address officially is 10 First Street Southeast, 10 First Street. The entrance to the building is off of First Street, and there are 2 staircases. The bottom one is ADA accessible. Both will be open for you to go to. You will need to pass through security. It's okay to bring a bag. We had a question from Laura about that. It's okay to bring in a bag, you just can't bring in a suitcase. And if there are questions about that, please talk to me. If you have a laptop in your bag, you will need to take it out of your bag to put it through security, kind of like in an airport. Please don't bring knives or explosives. Or if you have a bike key, sometimes they have blades on them. I've had some friends try to do that, and they make you like hide them in the bushes outside, so don't do that. We will, I think this was announced earlier, but in case I get questions about this, we will not be having red wine because it's a UNESCO World Heritage Site, and the wine might stain the floors, so we will be having white wine and beer if you choose to have alcohol. There will be light hors d'oeuvres. We made it start at 7 a little bit later so people would have a chance to go get a bite to eat before they join us. Let's see. Name tag, yes, please wear your name tag. And if you paid to have a guest, they are welcome to attend. This is just a personal thing because I've seen this happen before. The stairs are marble and they're very, very slippery, and I've actually seen people fall on them quite a number of times. So just be very aware of that as you're going up and down the stairs between levels. All of the exhibits are going to be open for you to peruse. Yeah. And then how to get there. So there's recommended directions on the site. There's 2 ways that you can get there by metro. You can do the Red Line to Union Station, and then you can walk a half a mile, or you can do Red Line to Blue and get off at Capitol South, which is closer. It's only a couple blocks from there. Technically, the Union Station one is the quickest way. Any questions from folks? No? Okay. Oh, okay. A fire? Right now? Oh, okay. Was it on the Metro or something? Oh, okay. Was this about Chris? Was this about your tweet? Oh, okay, great. Great. So there's no fire. Another question.
What is the minimum amount you suggest to have available on your Metro card?
Oh my gosh. I don't know. $4? $5? I'll take $7. Going once, going twice. Round trip, $7 or $8. $7 round trip. Even the cameraman is agreeing. Yes. Great question. Other questions? Okay. That was all the, oh, was there one over here? Well, the building closes to the public at like 5 or 5. Yeah, you won't be able to get into the building until 7 o'clock. Okay. So that was all the boring stuff. It's a beautiful building. We're really excited to have you guys, and we'll see you there. And if you think of a question, please tweet me. I'm at Jamie Mears or at LC Labs. Thanks.
All right, so I just have the wrap up for the rest of the day. And the only thing I have on here, it says, prompt start at 9 a.m. tomorrow, so don't stay out too late. Which I'm probably the worst person to give you that advice, but you should probably try to heed it. Don't stay out too late. Thank you, everyone, for a great day, and we will see you tomorrow bright and early.